on Zach's stream earlier. Got second place in his game. It's called 16. If you guys aren't following Zach yet, you definitely should be. But he's another awesome math streamer. He did, where was it? E to the 2i pi. Do I have him here? There we go. E to the 2i pi. Yeah, Zach. So he's developed like kind of like a fun like trivia type game. It's called 16. And this was us playing early this afternoon. So there's like math questions and all sorts of stuff. What's up, Smarty Pants? What's up, Click? So I think I got second place in this whole thing. Yeah, that's the leaderboard, but Femvox beat me out on on the challenge at the end. I barely beat out Inspector Diameter. That was actually pretty fun. But another awesome streamer. He does a lot of cool stuff. He's gonna do a big game. I think the last one is in December. But I'll make an announcement on my Discord. This one actually kind of snuck up on me. I didn't really make a big announcement about it in my Discord, but I will definitely make one. I usually do for whenever he's doing these games, but I'll definitely do a big announcement for his last one for the year. And y'all should all play. It's really fun. Anyways, let me get on my chat clients working real quick. 1 second. All right, we got YouTube chat working. Let's get TikTok running. Okay, I want to try to do this one, though. I'm curious. I know this isn't your question, Machka, but, I mean, okay, find a function for which all of the normal lines are tangent lines. You know some basics of English? I mean, that's good. English is a great thing to know. So, let's just, like, break this down a little bit. And then I may refer to the solution that was posted, but, okay, so a normal line is the same thing as, like, a perpendicular line, right? And this is something you learn in algebra. Right? That a perpendicular line has a slope that is the negative reciprocal of another line. Or of the regular function, I guess. Right? So, let's see. So, and then the other thing we know, right? Okay, so if I have a function, so all of the normal lines of f of x equals x squared. Okay, so are tangent lines. Okay, so f of x is equal to x squared. Let's say we wanted to figure out what the normal lines of this would be. Well, first I would need to know the slope of this function, which is a function of x. So I figure out f prime of x, right? And that's equal to 2x. Okay. So, the slope that is perpendicular to this would be negative 1 over 2x. Okay. Which all the normal lines are tangent lines. This is very interesting. Okay. So, and actually, let's just like draw this for a second. I want to see like what this looks like. So f of x is equal to x squared. Would look something like this. So then all the normal lines to this would be like this. These are all the normal lines, right? Because the normal lines point like perpendicular to what this is. I'm using Group World right now, Machka. So it's kind of like a whiteboard program. They're kind of old school. I've been using them for probably 15 years at this point. But here, if anybody wants to know who they are. Yeah, Group World. They're, I used them way back in probably like 2014. Because they were kind of the only ones around for online tutoring. And I just keep using them. And they're solid. Okay, so these would be all the lines, right? These are all the normal lines of f of x squared. Okay. And I know the slope of all these lines, at least, right? This is the slope of these lines. Is equal to this, right? It's equal to negative 1/2 x. But what's the equation of these lines? Because, sure, that's a slope. But if I wanted to figure out the equation of this line, that needs to be in some form of, I don't know, right? Let's say g of x. Yeah, let's say g of x. G of x, we know, is going to be equal to negative 1/2 x. And then it needs to be like plus b. So then how do we figure out this b? Well, again, when you're in algebra, right, you know if I have a slope. Sorry, negative 1 over 2x. Sorry, yeah, my bad. Sorry. Yeah, sorry. X was in the wrong place. Okay, there we go. Sorry. That's it. Okay. So when you're trying to find the equation of line and you got the slope, and you want to find the slope intercept, you just like plug a point back in, right? On the line. The interesting thing here is that the point we would plug back in, right, changes based on where we're calculating the normal line, right? But this point, right, is always located at x comma x squared, right? So I think plug that into here. So the y value, usually, right, when you have y equals mx plus b, we plug in a y, we plug in an x, then we solve for b. So let's do it. So if I plug in x squared here for this is equal to negative 1 over 2x, and then this is times x, and then plus b. Well, I think now I get an expression for b, right? So this cancels. So I get... Exactly. Yeah, no. I'm first finding the equation of all the normal lines. And then I'm going to like reverse engineer that to be the tangent lines of another function. I think that's the thought process. I first got x squared. I'm like, cool. And then I'm like, all right, well, what are all the normal lines to x squared? And then I know I have to take a function to make all the tangent lines equal to that. I think an integral shows up at some point. Okay, so this is 1/2 plus b. So that just tells me that b is equal to x squared minus 1/2. Okay, so now g of x, which is like our goal we're trying to get to, is negative 1 over 2x plus x squared minus 1/2. Right? Okay. All right, now let's come up with another function, h. Let's make this one, not blue. What color should we make this one? Let's make this one like pink. Okay. Yes, I can. Yes, definitely. Yeah, I came to freeze. If you want to submit a question to our queue, wow, there's already 7 questions in the queue. Okay, I'm going to work on those really soon. The website, actualofficehours.com. I'll go do them. Hello. Yo, thank you. Wow, that's my first hello for today. I have to get to 10. Yeah, apparently today is National Hello Day. You're supposed to say hi to 10 new people or something. Or 10, I don't know. Okay, so let's find the function h of x then. Okay, and I need our tangent lines. Okay. So h of x equals something. So the tangent line to h of x would be, Wait. The function's h of x. Okay. And then let's say this is like the tangent lines, which I'm like running out of symbols at this point. Ooh, let's say z of x. Okay. So I know z of x needs to equal this, but z of x would also be equal to h prime of x times x, and then plus b. And then we can figure out what, so right, because this would be the slope of my tangent line, which is the derivative of the function h. And then to find b, I would also plug in what? I would say like, okay, so h of x equals h prime of x plus b. So b equals h of x minus h prime of x times x. Very interesting. Okay. So what does that get me? So z of x is now equal to h prime of x. Well, this is kind of weird then. Wait, h prime of x times x plus h of x minus h prime of x times x. Well, now this is just z of x equals h of x. I don't believe in this, actually. Where am I stuck? I think that the issue comes in me like using x too many times. What's up, Samsung? What did you find the slopes of the tangent lines to be? I found it to be h prime of x. Which I guess, I know, sorry. This is the equation for the normal lines. So this is the equation. This is the equation of the normal lines. Oh, which is supposed to be the equation of the tangent lines of z. Yes. And I said, okay, well, the tangent lines of z. Well, sorry, the tangent lines of h, which I'm calling z. Yeah, but what about the b? This is where I'm curious about, because I need the, this is the equation of the normal lines, but I need this to be equal to the equation to the tangent lines of h. Right? This eventually needs to equal g. Here, let me use different colors, sorry. So I was saying, let's say the function is h. The tangent lines of h should be h prime of x, right? Times x, and then plus like some intercept. I don't think it's an optimization problem. Consider one for a second. Oh, you mean for this one? Sure. I mean, that's just g of x equals... well, that's interesting. Oh, I think I see what's happening. I'm using too many x's. Right, because this isn't a line anymore. This is a curve. Oopsies. I see what's happening. There are too many x's. Yes. This is a yeah, exactly. Oh, I see why this is... Oh, this is curious, actually. This is cool. Yeah, this is no longer... Okay, so I need to... Yeah, okay, I got you. I see what you're saying. I see what you're saying. Yes, this x is different than this x. Got you. Fascinating. Right. Oh, wow. The Simpsons rule. Well, let's see. So chat did actually come up with a solution for this. I want to see, like, I think the parameterization is the part here that we're kind of missing. Right, so they use it as t. Okay, so they use t to, like, define where you are along it. This is not Calc 1, no, this is actually... Think of this as a one-parameter family of lines. Oh, okay. It's actually pretty cool. Wait, but what? Fix the latex. Fix the latex, please. Can't I see this? Parametric envelope. Yeah, this part's... And then this is apparently the last one. This is crazy, though. How did we get to this? Okay. I see, Machka, why this question is tricky. I think you want this to be, like, of t. Yeah, I think this is what happens. I think this is t squared. It's called the evolute of a curve? Oh, that's cool. I didn't know that. Yeah, wait, let's call this t comma t squared. This is not Calc 3 at all. No, this is just kind of a fun little challenge problem that someone submitted to my Discord. But I already have 10 questions about this stuff, so I'm probably going to pass on this real quickly here. I just want to see if I can get a little bit further on it. Yeah, okay, so now b would be equal to t squared minus 1 over 2x t then, right? Or no, I think the t goes here then? This is the interesting thing, because g is now a function of x and of, like, t, of, like, where you're at. I think maybe it becomes this. Let me see. I think I'm close. Yeah, so they said y is equal to t squared. Okay, so this should be, yeah, this should be t squared. Yeah, I agree with that. T squared minus 1/2 t. Yeah. T squared, they have plus 1/2 t minus 1/2 x over 2t. Yes, okay, I think I see this. I think this should be t. This should be x. And then we should leave this actually as an x. Sorry, actually, I think I know what sorry. This is what I want. This is t. This is t. Then we do this. No, but I don't have an x squared in it. Meow. Okay. I'm gonna move on to the next question. This is fun. If someone wants to actually, like, try to, like, explain this a little better to me, I think I'm getting close. But there's differences with the x's and the t's. Yeah, that'd be cool, Machka. Oh yeah. I appreciate if you think you can find a. Yeah, the parametric envelope thing. Like, I'm close, but I'm getting a little confused with, like, all the x's and t's that are floating around, and, like, which one's which. But I appreciate, like, you, like, bugging me about it. Or not bugging about it, bringing it to my attention. All right, let's see. Because I already got 10 questions I got asked today. All right, here we go. All right, see, Joseph H. Jaws here. Let me do someone who hasn't asked a question yet. Jaws, you've never asked a question, so let me do yours real quick, and then I will come back to my regulars who I know always ask questions. Stop stealing my name. Oh, I thought that was you, actually, Joseph. I thought that was you. That's not you. Okay. Evaluate the surface integral where S is the cone, equal to that. And then compute the surface integral of z minus x d. So this, okay, this is surface area, right? This is like a surface area integral. Okay, I think usually we want to do this in cylindrical coordinates, right? Right, so like in cylindrical. X squared plus y squared is equal to r squared. And then let me think about, like, what this cone looks like. It's always kind of fun to watch. So in this case, that means z is equal to r. Okay. Have we done this before, Jeff? I'm pretty sure I've done this. Maybe I haven't done this part of it. I've definitely done, like, calculate the volume integral of the cone, but this is the cone, right? And so z is going to go from 0 to 1. So, I mean, that means r goes from 0 to 1 as well. So, yeah, we'll use this, and then we're going to use, like, x is equal to r cosine theta, y is equal to r sine theta, and then z is just equal to z, right? But, oh, in this case, z is also equal to r. That's actually kind of fun. Okay, so if I'm doing my surface integral, right, d theta is now going to be just dr d theta. I see. And that means that, so dr is going to go from 0 to 1. D theta is going to go from 0 to 2 pi. But then we just need to, like, write out what this is. So, in this case, z was equal to r. And then x is r cosine theta. Okay. But then, there's another r on my surface integral, right? Yeah, wait. This is where we have to do, okay. I have to do like a Jacobian thing here, right? Okay, if this is my parameterization, I think you have to do like, it's like, and we're going to do things just in terms of r and theta. I have to do like r theta cross, r. And this gets me like what is it? The volume integral, the surface volume integral thing. Yeah, okay. All right, so we said that r was going to be parameterized by this. So this is nice. So basically, we took something that was a function of x, y, and z, and now we're making it as just a function of r and theta. So that now when I do my surface area integral, I only have to worry about r and theta. And what that was, we were saying like, okay, so r vector as a function of r and theta was equal to r cosine theta, comma r sine theta, comma r, because z is equal to r by this definition of a cone. So then r theta is equal to dr d theta, and that's going to be equal to negative r sine theta, r cosine theta, 0. Right? Cool. And then r as a function of r, or partial r, so that's dr, that's going to be equal to cosine theta, sine theta, comma 1. So now if I cross product this, how to make some beats? Yeah, we had a music production stream once. You remember that? That was a fun one. You remember when we did that? What's up, Legendary? Okay. So let's do r theta cross r. So that becomes this. So you have to do I, J, K, and then we're going to do this. So this is negative r sine theta, r cosine theta, 0. I want to learn how to mix in bass with the drums and the vocals. Yeah. It's all about creating space in frequency. Music is math too, by the way. Yeah. So a lot of mixing in like music production comes down to knowing the frequency bands that your different elements are sitting at, and then carving out, they say, like space inside a song such that things don't clash. So for instance, you usually cut out all the low end on your vocals because you don't want it to compete with the kick or the bass. I mean, YouTube is great for learning. If you want like software to produce, Fruity Loops is the cheapest thing that people start out. Ableton is like the standard. I use Ableton. Yeah. Can you explain line integrals to me? If you submit a question over it, I'll go over it. But yeah, line integrals is just like integrating along a path. Regular integrals, you usually do like, I mean, they kind of are line integrals, right? But you're doing it strictly along the x-axis. I think what you're maybe thinking about is like path integrals too. So that's where like you're integrating some other like parametric function like as you go down a path. I don't know what Soundtrap is. I know the standards for music production is like FL Studio, Ableton, Logic, Reason, and Pro Tools. The determinant of a matrix with IJK as the top row is the only way I can... Yeah, exactly. I mean, there are ways to notice, like, what components will be 0. So, for instance, if you ever have, like, something with X hat crossed with something with Y hat, that's always going to get you something with Z hat. And then also, like, Y cross Z will always give you X hat. And then Z cross X will always give you Y hat. Okay, Henry says, I don't really understand the reparameterization aspect. Okay, that's fine. All right, so let's talk about this, right? So when you want to compute, like, so this is the surface area of something, which is usually equal to, like, dx dy, right? So, for instance, if I have... I'm trying to figure out something over the surface here. In, like, let's just say in 2 dimensions, right? I look at stuff, this is Calc 3, over dx, I look at this over, like, dy. And that gets me, multiplying those two things together, like a square, gets me dA. When we do, in intro calculus, when we're doing just, like, single integrals, when I do, like, blah, 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 like dx, what we're doing is we're looking at, like, what the height of some function is. So this is, like, f of x is. And then it has, like, some tiny width, dx. Can you teach maybe a very little faster? No. A very little faster? The fuck's a very little faster? Also, I teach to whatever speed so people can understand. Yeah. I do stats as well. So Henry, this is when things are in nice 2-dimensional space. I can just do dx dy. The issue here in 3-dimensional space is, and especially when this 3-dimensional space is confined to, like, a certain shape, is that I now have things in X, Y, and Z, and I'm trying to figure out, like, what this, like, individual little surface area element is. So what a reparameterization does is it takes something here in 3 dimensions. So this is a function of X, Y, and Z, and we're gonna, like, flatten it down to something that's a function of just 2 variables, which in this case is R and theta, okay? So now, when I'm looking in my space, I've taken this cone and I've, like, smushed it, such that now this thing is just defined as, like, some R, and then, like, where I am along in terms of theta. Skip mine, by the way. I got called to action. Okay, all good. But in doing this parameterization, so this is like dx, dy, dz. You have to use this, which is now taking the derivatives of your parameterization, which this is my parameterization, right? This is the parameterization. This takes something from x, y, and z and makes it into a function of just r and theta. And then if we take the derivative of this with respect to my 2 parameterization matrices and then take the cross product of it, that gives me what my new, like, dA is here. In this case, like, dA is kind of just, like, equal to, like, dx cross dy. The cross product is, dA is always a vector too, which points, like, upwards from whatever the surface is. Wouldn't you want R, H, and theta? No, because surface area I want just 2. I just want two vectors. If it was a volume integral, then yes, I would want 3. That makes more sense? Yes. You're welcome, Henry. This is also why I sometimes go slowly when teaching, because I want to make sure people get it. Your teachers in your classes, yeah, they're restricted by time. They have to just teach. They have to teach quickly. They have to teach fast, because if they don't, they lose their job. I could give 2 fucks how long it takes for me to, like, do a question, because at the end of the day, this is my stream. So no one tells me, like, you have to do this in this certain amount of time. I do it in as much time as we need for someone to understand it. Which, Henry at least understands it a little bit more now. Yes, good. It is, yes, exactly. It's a surface area question. So that's why we have to put it in terms of 2 variables. So visually, what I think about is that you have a 3D shape and you're smushing it down to be like a 2D shape. And then you need to come up with, okay, well, what's that new D whatever? Like, what's my new DRD theta? Yeah, Professor Speedrunning Math be like, the proof is by magic, yeah. Yeah, or they're like, oh, this is an exercise for the reader. I'm like, no, fuckface. Like, hold up, dude. Like, how did you get that? Okay, so this ends up becoming R. This is going to be R cosine theta. And then we're going to get the magnitude of this. So here, let's get the vector first. So it's R cosine theta. And then when we do this one, it's minus R sine theta. So that's going to be positive R sine theta. Okay. And then when we do this one, what's that going to be? Minus R sine squared theta minus R cosine squared theta. Oh, this is actually really fun, right? Because this shit is just 1. Right? Sine squared plus cosine squared is 1. So this gets you... if it's a cross product, would it be a parallelogram? Yes, technically. But parallelograms are kind of... And then more importantly, tilde, it's like the area of a parallelogram. Is when you take the cross product of 2 vectors. Here, let me show you that. Yeah, so this is what happens. So when you have like A cross B, that gets you the area of the parallelogram. So when we're doing this like DRD theta thing, we're getting like what the area element is of that new DA. Yes, it is, exactly. Yes. Yeah, so, yes, and that's what we're going to do. So I'm first finding what R theta cross R dot R is, and that's this. So this is R cosine theta, R sine theta, and then this is just negative R. But now I want the magnitude of that, because that's now the area of this. And so that's going to be R squared cosine squared theta plus R squared sine squared theta, and then plus R squared, I guess. So that's R squared 1, right? Oh, and it's the square root of all this, right? Yeah. Oh, so sorry, yeah. Magnitude, right, is this squared plus this squared plus this squared all square rooted. So now I can pull the R out, and that's cosine squared plus sine squared, which is just 1 plus 1. So this is equal to R squared of 2. Okay, cool. So that's what the parameterization did, is that now I know this, and then this is like DRD theta. This is R squared of 2. Cool. So that's our new surface area integral. If it was just a straight circle, right? Let's say it wasn't like a cone. Let's say it was a flattened 2D cone. This would have just been R DRD theta, right? Okay, so now we have this. And I think we're just doing integrals at this point, maybe. Now I can go fast. Yes, so the limits of the integral. So I have to think to myself, okay, what are the limits on R? Well, remember that x squared plus y squared was r squared, so this was z is equal to r, but z is restricted from 0 to 1. So that means r is also restricted from 0 to 1. That's the Jacobian. Yes, short shadow. Yep, exactly.
Good job.
And then theta is almost always just going to be 0. It's almost always just going to be like 0 to 2 pi. Just because things are symmetric about whatever the z-axis. And so you have to rotate all the way around. Yeah. This is almost always going to be 0 to 2 pi. Okay, so whatever. I got a square root of 2. I got a 0 to 2 pi. I have a 0 to 1, but now the r needs to multiply by both things here. So I get r squared minus r squared cosine theta. And then this is dr d theta. Okay, so if we do the dr integral, that's going to give me r to the third minus r to the third. And then that's a 1 and a 0. Yes, I love rate law. Chemistry stuff is great. And actually, JC would love if I did some chemistry. So please submit a chemistry question. R to the third over 3 minus r to the third over 3 cosine theta. And then that's evaluated from 0 to 1 because that was my dr. So the 0 is just going to go away. So I can replace this all as 1s. So this is 0 to 2 pi. And then here, let's pull the 3 out as well. And that's 1 minus cosine theta. D theta. What's up, Maurizio? All right, now this is an easy integral to do because integral of something d theta is just theta. So that's square root of 2 over 3. And then we have theta, and integral of cosine is sine. So we have minus sine theta. And then this is evaluated from 0 to 2 pi. Well, anytime you see like just sine theta by itself from 0 to 2 pi, this goes away when you do the limits of the integrand. And then this is just going to get me a 2 pi. So the answer should be 2 pi square root of 3 over 3. I want to say that's what it is. Or square root of 2. Sorry. I don't know why I wrote a 3. What's my background? I have a PhD in physics. And I teach a lot of math. I teach all science, chemistry, whatever. Stats. Middle school, high school stuff. Okay, nice. Cool. There you go. That is the answer. Nice. Great question. Actually, I really like that one. What kind of math is this? This is... I want to say this is multivariable calculus. So like Calc 3. Alright, nice. Okay, that was Jaws' question. We got a lot of questions today, actually. It's kind of cool. Let me pull it up. Can I do Calc 4? What's Calc 4? What is Calc 4, dude? What? Dun, dun. Good evening, Dr. Gold. Yeah, what's up, mathematic fanatic? My dude Waldo, bro. What's going on, dude? We just did a fun little parameterization question here. All right, let's pull that in. Nice. Also, make sure... okay, so those that are just watching us right now, how this works is there's a website here, www.actualofficehours.com. This is where you can drop in screenshots of your questions, upload them. We'll do them during the stream. And then all the questions we do, we eventually post in our Discord here. So make sure to go join our Discord because that's the channel where all the screenshots get posted and all the solutions. So for instance, this is Jaws' solution that we just did. And so I'll post all the work to it. But you can get there by joining our Discord. And then also the recordings for all this get posted on YouTube. So make sure, go follow us on YouTube. Or they also get posted on Twitch where they're in nice like horizontal format. Yeah. Deflection of beams. What do you mean? Maybe. Sounds like stuff. Yes. There we go. We do have a lot of questions. Yes. So here's the other thing. If I don't get to all the questions, I honestly, I will probably... Here, I'm gonna give you guys more time anyways. I wanted to go out tonight, but... Alright, I'll push it another 30 at least. I'll make the timer longer for you guys. If we don't get to all the questions today, they still get posted in our Discord. And then what happens is we have another awesome set of actual educators who will go through in their spare time and just like solve them. or they'll do it on their own stream. Or Zach will be streaming as well tomorrow morning doing math. And so make sure if you go to the streaming schedule here, you can go see all the other people who stream and when they stream. And so Zach has a stream tomorrow morning, and he can help out with math questions too. Doing the Lord's work, yes. Teach us derivatives. Please, Angel, I'm there with you. Yes, I've never done anything like that. Where would you recommend starting out for someone who's been out of math for like 7 years? Join our Discord, because I'm about to launch a free like remedial math course thing. So if you go to our website, Actual Education, this is not live yet. It's going to be live in the next day or two. But I have, I call it like a math boot camp. And it's going to be a free course you can run through that teaches all the basics of like getting back into math. I used it while I was teaching at UCLA as the first week of classes for my physics lectures, because I needed students to know some basic math stuff like exponents, fractions, I don't know, like slopes, so that they could do physics. And so it's the same course I ran them through. We're going to make it available for everybody else, free. Kudu's being nice, they're hosting it for free. And that's a way for you to like kind of like get your skills back up to par on things. So, yeah. Stochastic processes, maybe. If I don't, I already know people who do. I do know people who do, so. Alright, let's see. What else is... Alright, so let me go through some questions. Engineering degrees are great if you're trying to be an engineer. Don't get a PhD in engineering unless you're trying to teach. This is more Jacobian stuff. H has one. Let me do some physics. Let me do H's. Joseph, are you here? You submitted yours like earlier. This just seems like it might be hard. I'm debating if I want to do this one. Do we think this one is like tricky to do? Let me do some physics real quick. I'm gonna do H's. H has a physics question, and then I'll maybe take a look at that. Oh, do you know where you can learn them? I mean, you guys have the internet. You also have like ChatGPT. Chat is actually really good at teaching. It's probably gonna put a lot of like mediocre teachers out of a job. Like, and I say that with like love, because you know teachers need to like give more of a shit. Like some teachers like don't really give a fuck when they're teaching, and I think that's gonna get replaced by AI. But I think what will shine are the people who actually care about teaching, because that can't be replaced by AI. What's up, Hummer? It's Friday. What's up, Zach? Yes, shout out to Zach. He's another awesome math streamer, which I got second place in his game today. FemFox beat me. I should have wagered 5 questions. I think I would have gotten close. If I'd wagered everything, but I also wanted to get on your leaderboard, so I was safe today. Yeah, I agree, Hummer. Yeah, it's a little sycophantic. But the best way to figure out if you know something is try to do questions. Like try to do this. Okay, in about 5 billion years, the sun will evolve to a red giant. Assume that its surface temperature will decrease to about half its present value, while its present radius will increase. Calculate the ratio of the total power emitted by the sun to its present power. That's cool. So this is black body radiation, no? He is the answer key. Black body radiation. I think the only reason I had a chance against FemVox today was that he got timed out for typing the answer too many times. Where's the equation I want? It's something like t to the 4th. Is it called Wien's law? No. Fuck. Ah. Uh-huh. It's similar to this. Stefan-Boltzmann, that's what I want. Okay, thank you. Thank you. There we go. That's what I want. I'm like, it's one of these Germans. One of these Germans has a law that does it. The Wiener law. Okay, here we go. This is the equation I want. All right. So power over area is equal to sigma, which is a constant, not being cool. And then t to the 4th. 2 of these Germans, yeah. Okay, so this means that power is equal to a sigma t to the 4th. What's this lowercase jewel bullshit? Joules are capital.
Good job.
All right, so they want the ratio of the power emitted in red giant to present. Okay. So we want P future over P present, PP, I guess. Okay. So that's going to be equal to the area in the future. So this is cool. So area, we know for spheres is equal to 4 pi r squared. So I'm going to say 4 pi, and this is going to be 1.5 times 10 to the 11th squared. Sigma is going to be the same, actually, so I can get rid of that, honestly. And then we said the temperature was going to decrease to half its present value. So that means it's going to be 3000 K. And then we need to divide this. Do I have an intuition of why it's t to the 4th? I don't, actually. I think it has to do with, again, with the other laws I was trying to talk about, Wien's law and stuff. It probably has something to do with, like, E is equal to HF, which is, like, HC over lambda. But then lambda is, like, related to, like, this weird-ass curve, which is something as a function of t. And I think that's eventually where you get t to the 4th. Yeah, you don't really see a lot of t to the 4th. You don't. Yeah, I'd have to ask one of my, like, astrophysics people probably knows it more than I do. Okay, and then this is 7 times 10 to the 8th. This would be in a physics class. It could be in a undergrad physics class. This is 6,000. Because it's not too complicated. They're kind of like just dipping their toes into black body radiation. So maybe like physics 2 or physics 3. All right, 4 pi's cancel. Sigmas cancel. This is just going to be 1/2, which is nice. So then you get this 10 to the 11 over 7 times 10 to the 8th squared times 1/2, and then we got a needs. Looks like foreign scripture. Yeah, some of the stuff can start looking like Chinese for sure. Technically, it's Arabic numerals. All right, pull up the calc. What do we got? All right, so 1.5 e to the 11th divided by 7 e to the 8th. Thank you. It's 1/2 to the 4th. Thank you. I fucked that up. Yeah, thank you. Okay, so that's that squared. So yeah, good catch, by the way. Sorry. This is this to the 4th. Very good catch, by the way. So that's 1/2 to the 4th. So 1/2 to the 4th is 16. 1/16, right? Okay, so divide that by 16. Okay, so we get 2,869.9. So the sun will become almost 3,000 times more powerful. Yeah. Nice, cool. There you go. Nice, good answer there. Good question, H. Appreciate it.
Good job.
Redon says, I have an electrical engineering test on Monday. How cooked am I? Depends what the test's on. And it is Friday. You still got Saturday and Sunday to study. That's H's question. Hidden gem of a channel. Thanks, Kenny, dude. I like to think we're gems. You're all gems. Alright, cool. Seriously underrated. Yeah. Well, we may be getting more ratings. So, I mean, we did make it to 10,000 subs on YouTube. It's kind of plateaued right now, but I'm gonna in a week and a couple days we're gonna do a 24-hour stream, which I think will boost us back up into having ratings. Because like, who the fuck has done a 24-hour tutoring stream? I don't know many people. Zach, I do need to talk to you about that. I will do it. It's on my list of things. To be fair, I only got no writing stuff to do. It's just problem solving. Okay, nice. Yes, dude. JC, if you wanna post that in the good grades thing that you pass your driving test, congrats, my boy. Passing your driving test in the UK is a lot harder than the US. The US, they're just like, oh great, you got like a fucking license. They don't really, we don't really test very hard. It's very difficult actually in the UK to get, especially like a motorcycle license. I think you have to have someone like follow you around for like hours. Okay, let's see. All circles in the diagram. Yeah, exactly. It is crazy. Which it should be, you know. We give licenses to fucking anyone out here in the US. It's dangerous. Boom. All circles are 5 units apart from each other. Find the gray area. So wait, aren't these centers of the circle? I think these are, right? Isn't this a center? This is a center, and this is a center. Because they all have radii of 5, and they're all 5 units apart. My major was physics. I know so much because I've like tutored everything. This looks like a rouleau. For this problem, you can find intersection points and integrate y of x. Yeah, I guess we could. Like, are you saying, I want to know if there's an intuitive geometric way to do this. I do agree I can just do this, though, right? There's always a, you know, when in doubt, just fucking plot it out. Integrate and remove 2 triangles. Yeah. I think I have to add 2 triangles, no? Because, yeah, here's what I'm going to do. I can get this. This is easy to get, right? This is pretty easy to get. But then I need to get this part. Half of the intersection of 2 and a cone minus a triangle. We have done this, right? So I do know what this area already is, right? We've done that question many times. And then I just have to subtract this out, is what we're saying? Or just add it. I have so many people with so many ideas. I think there's a lot of ways to do this one. Yes. Okay, here. I think I know how I'm going to do this. I know this is 5. I know this is 5. Right? So, and then the intersection point here, where they intersect. I think we find that that's like, isn't that like 60 degrees or something? Move the origin to the middle one, though. Then just do the right half. Okay, they want me to go here. There, you want me to do that? Oh, this is actually pretty then. And then just do this. Wait. No, he says no. Move it to 0, 5. I meant this is 0, 5. Oh, so the middle dot is... Oh, I see. So you want this. But... Jeff says this is gorgeous. Do you think this is... I don't like this, though. Because then what's the equation for this from here? It's like a shift. It's like a shifted circle. Yeah, but y of x is not nice now. I do know that, yeah. I have so many suggestions in chat. This is almost like analysis paralysis because there's so many different ways to do this question. Why am I complicating everything? It's because I have 3 different chats going off. That's why. Yes. Okay. Well, all right. We'll do Jeff's way. Jeff's way sounds kind of fun. So yeah, what? This would be 2.5 then, right? Located around. So if I want the equation of I see. I think I see what he's saying. Jeff's way is complicated for nothing. Jeff, they don't like your way, dude. But I do no. I do like Jeff's way. I do. Here. Yeah, you suggest something, Hummer. I think I see what Jeff's talking about. Like, okay, so like this is going to be for this triangle. And then this curve right here is going to be for this circle, sorry. And actually, I only have to figure out one of them, right? Because I can, if I just figure out this area, can I just multiply it by 2? Because I know it's symmetric. Exactly. No, I agree with you. And then I'll need to do whatever this one is, right? For this circle. So yeah, so let's draw like what these triangles would be. Yeah, actually, I think I kind of like Jeff's way, honestly. It's kind of, there's a lot of ways to do this one. And again, I invite you guys to join my Discord. And if you have a way you want to show how to do it, please do. I'd love to see it. Okay, so for this circle, this is a circle that is just shifted to the left in x by 2.5 or 5/2. So that would be x plus 5/2 squared plus y squared is equal to, and the radius is 5, so 25. Okay? So this means that y is equal to the square root of 25 minus x plus 5/2 squared. And it's plus or minus, but I only care about the plus root, right? And then we're going to integrate that from 0 to 2.5. Yeah, let's make the... Well, the queue is very long. I already have 12 questions. I can't fucking take forever. Okay, so the integral from 0 to 5/2 of this, right? Dx. That would give me this then. Right, Jeff? This is not an easy integral to do, though. Yes, I could make equilateral triangles. Right, Jeff? I don't know if this is the nicest integral to do. How do you do this one? It's like arc sine or something? Yeah. I could use polar. Yes, that's another way, Jamie. Let's see if this works. Sorry, what is it for arc sine? Integral thingy. That's 1 over the square root of 1 minus, though. This is like trig is it trig substitution integral stuff? Yeah, here you go. No, I still think it's arc sine. Yeah, I'm gonna use trig substitution, Jamie. I'm definitely gonna do it. I have to do like trig substitution and u substitution though. Right? Because anytime we see square root of a squared minus x squared, use this substitution. Yes, thank you. Yeah, so I'm going to say that, well, no. First of all, I have to say that, You can do it. I thank you guys. I trust. Your encouragement only makes me stronger or something. Okay. Yes. Got it. Okay. I need that to become... Okay, so x plus 5 halves needs to be equal to 5 sine of t, right? So then x is equal to 5 sine of t minus 5 halves. So then when then dx is just equal to 5 cosine of t, right? So now when I plug that in, don't worry about the bounds for now. I get the square root of 25 minus, so this goes in for x, so the minus 5 halves kills off the 5 halves. And then I'm just left with 5 sine t squared, so then that's minus 25 sine squared t. And then my dx is now... Right, so if that x is that, so dx is 5 cosine t dt. This is 5 cosine t dt. This becomes pulling a 5 out. And that's 1 minus sine squared t. Oh, there's another 5. Okay, so make that 25. Cosine t dt. But then 1 minus sine squared is cosine squared. But then the square root of cosine squared is cosine. So this is cosine squared t dt. Okay, now I need this integral though. This is, oh, man, what's the integral? I'm starting to think the triangles might have been a bit better. It's a double. I agree. It is. I agree. Here, I'm just gonna use it. I'm just here. I know the argument is to do a double angle, but for the sake of time, I'm just gonna like pop it out. Yep, Jamie, you're right. But here, we're just gonna use it. So this is 25, and then this is t over 2 plus... Yes, I agree. We're doing it because I just want to do it. Jeff suggested it. We're gonna see if it works. Shouldn't it be cosine t? Sorry. Correct. However, we're assuming it's positive, right? I'm only doing integrals over the positive area. I'm gonna multiply by 2 anyways. Cosine's positive. No, Jeff, stop. I'm not using e to the it. Okay. But then, okay. And then, but now I need to resub in what t was. So this is where this kind of sucks though. Because x plus 5 halves all over 5 is equal to sine t. So t is equal to the arc sine of x plus 5 over 2 over 5. Right? That's not going to make my life very easy, is it? Oh, God. 25. No, I think it's a 5. Well, because look, so I pulled a 5 out of here, right? And then, but I also had a 5 from my dx. So that's why that hit the 25. No, we haven't figured out t yet. No. This has nothing to do with the shape. This is strictly just trying to figure out the integral. Oh, man. Jeff, I don't know about this. I don't think I want to do this. Bro, I don't want to find out what the arc sine of this bitch is. Over 2 plus 1/4 sine of 2 times. Oh, dude, no. Yeah, like, what's arc sine of 2? Dude, no. Okay, no. All right, I can't go down this path anymore, Jeff. I'm sorry. You are right in, like, it should work, but, bro, this is the fuggliest integral I've ever seen. I don't want to do it. Jamie says it'll be fine when we plug the limits in. You think so? From 0 to 5 halves? Alright, he says keep going. Alright, I will keep going. Okay, and then this is from 0 to 5 halves. Let's see. Let's see. Thanks, Jamie. Okay. Alright, yeah, okay, so let's do it. Alright, so 25. This is going to be the arc sine of 5 halves plus 5 halves. It's 5 over 5. So arc sine of 1 over 2 plus a quarter. The sine of 2 times the arc sine of 1. Okay. And then minus 25 times the arc sine of 1/2 plus a quarter. It is actually kind of nice. Yeah, okay, fine. All right. We stuck with it. I stuck with it. Thank you, Jamie. I was about to give up on this. Okay. Arc sine of 1 is pi over 2. Okay. So we get 25 pi over 4 plus a quarter. But then the sine of pi over 2 times 2 is the sine of pi. Sine of pi is 0. So this is 0. Yes. Well, we usually we'll say this, Gavin, by the way, too. This is another way to write it. They'll just say arc sine. Okay. And then this is minus 25. Arc sine of 1/2 is pi over 6. Right? So this is pi over 12 then? Yeah, okay. Plus 1/4 the sine of, so that gives you pi over 6, but times 2 is pi over 3, but the sine of pi over 3 is square root of 3 over 2. Yeah? What's the Q at? Here, the Q's right here. There's the Q. It's already 14 questions deep. Yeah, this is the question we're doing. It's the first question. This is the first question on the list. Busy tonight, yeah. I got a lot of people tonight. It's kind of cool. It's Friday. Okay. So square root of 3 over 4? Sorry, where do we get square root of? Or 1/2 times the square root of 3 over 4. Oh, okay. Yes, that's another way to think of it. Okay, cool. Oh, I see, because you want to maybe combine these two things. Okay. Nice. Yeah, we're doing some math. Come, relax, enjoy the hors d'oeuvres. There's fresh lemonade in the back. All right, this is pi over 4 minus pi over 12 plus a quarter minus a quarter times square root of 3 over 2. Yeah. Okay. And that was just for this, by the way. That was just for this. Milk, lemonade in the back. In the back, the fudge is made. Oh, is this a fucking... You're making a butt stuff joke, Jeff, dude? Alright, that's all this was. Oh, and then, so then we need to multiply that by 2. Okay. Oh, man. All right, so then the last part is to get this. Which I think this is also going to be absolutely hideous. Right? No, I had lemonade at a funeral yesterday and I liked it. That's why I said lemonade. Okay. Which one did we integrate? We integrated this. This is the integral we so actually I could check real quick. Let me throw this in the chat. Just like make sure we did this integral correctly. Chastity, no, ChatGPT. Just see if it solves it real quick. Oh, which circle it is? Oh, yeah. So we just figured out this. So we did this area here, which was for the purple circle. I agree, Jamie. So maybe I'll just give the integral to ChatGPT and like this will be like exercise for the reader. Just fucking do it again. For the last little bit, the shape is the same. So how about you rotate it, then subtract the right angled triangle? What is it right? What do you guys keep talking about like a right triangle? I know if eventually if I did this, right, that like I could do this area and then I subtract like the triangle from it to then get what this is. Is that what you guys are saying? Oh, wait. I think I see what he's saying. So sorry. I could get this pretty easily, right? And then you want me to just remove this part of the triangle? No. Rotate it so it fits the last bit, then form a triangle from the bottom two red points to that point. Rotate it so it fits the last bit. Yes, I agree this is minus a root 3 over 4. Yeah, it's hard for me to like decipher all the text of like what people are saying. It's getting close. Do we know this is a sixth, by the way? How do we know this is a sixth? Oh, because this is an equilateral triangle, I guess, right? Yeah. Sure, mathematician. This is the equation I used for the equation of the circle. That's for the purple one. Oh. Oh, this is actually genius. Uh-huh. Oh, so then I would do like, you remove half the triangle. So like that. Yes, I agree. Okay. So, I see what you're saying. Thank you. Yeah, no, that's great. Okay. So, yeah, so this area here is a sixth of a triangle, right? So that's 1/6 times pi times 25. And then we're going to subtract that from this triangle, which is 2.5 by 5. So minus 1/2, 2.5 times 5. Right? Uh-huh. How did you figure out x plus 2? Well, all of them have a radius of 5. So this triangle is shifted over by 2.5, 5 halves. Right? Because the distance between all of these is 5. This is a cool question. Okay. So we have 25 pi over 6 minus 5 halves. So 5 halves times 5 is 25 over 4. And this is equal to this little area. Well, here, one sec. It's actually very cool how this works. Okay, so that was that. And then this, I'm running out of colors, unfortunately. The banana, I love, is what you guys are talking to it. All right, this is the pink thing right here. Okay, cool. Why is he? No, we're done, right? That's what this is, right? Cool. So I just do this plus this times 2. So whatever this, like, caustic mess was. Half a banana, yes. Can someone find a third method to torture Dr. Gold with? Just need to stop. Stop. This is the ultimate troll question, because there's so many ways to do it. Alright, so this is pi over 6. I'm just simplifying this rule, just so I feel better about myself. Okay. Pi over 6, plus a quarter, 1 minus the square root of 3 over 2. Cool. Yeah, if I really wanted to waste time, I could. Oh, Jesus, that's too big. Alright, sorry, 1 sec. So 25 pi over 6 plus a quarter. 1 minus the square root of 3 over 2. That's equal to the blue section. Remember, guys, don't do this at your exam yet. This would not be an exam question. This is a fucking troll, like, competition question. Okay, so then you do this. And you multiply by 2. So, add and double. It's not very nice, though, is it? Well, wait, I do see a 25 pi over 6, a 25 pi over 6. Make it 3 spheres? Jesus. What's up, Edvin? How's your classes going, Edvin? Okay, so this is 25 pi over 6 plus 25 pi over 6 plus 25 over 4, right, from here, minus 25 over 4. That's actually kind of nice. Those are canceling. And then minus 25 square root of 3 over 2. Okay. So this is 25 pi over 3 minus 25 square root of 3 over 2. And then we're going to double it. So what does that get me? 50 pi over 3 minus the square root of 3 over 2. Nice, dude. I'm glad. I think this is the final answer. Is it? Is it the final answer, though? Where's Joseph's question? Okay, this looked hopeful, I think. It came out kind of clean. Let's ask chat to just solve it. I'm just curious. This is what they got for their integral, though. I don't know if I like that. Yeah, I'm ready for a break, too, honestly. Let me see if that comes out to be the same. 25 over 24. Okay. So they're saying if I pull the 6 out... Oh, wait, what are they doing? I don't know if I'm going to get the same answers they got. 4 minus the square root of 3. Fuck. Okay, let's see. Okay, this is apparently the accepted solution. Dang. Okay. So I'm close. I'm off by a factor of a half somewhere. And then a third somewhere else. Okay. I think something went wrong doing this integral to get to here. I would love for you to write it up, okay? It's root 3 over 4 plus 3. Wait, where's the 25 though? There's got to be 5 in there somewhere. Okay, here's what I'm gonna do. This was really fun.
Yeah.
I appreciated the group effort of everyone on this question. I am gonna post this in my Discord, so I'm gonna mark this one as done. And if anybody else wants to like join the thread that gets in there and go through it, I'd love to see it. Yeah, maybe where I put an X on the 0. Yeah. But arc sine of 1 is arc sine of 1 is pi over 2, right? And then sine of 2 times pi over 2 is 0. It should be 0. Polar integrate the banana. Get out of here, dude.
Get out!
Okay. So here's what's gonna happen, because in the Discord you will see a thread here under homework help with Joseph's question. And I have the solution of what I did. Or what we did. This was very much a very big group effort with everyone yelling at me different ways to do this question. So please feel free to like post in here like what. So I'd be like, we were close, but made an error. The link to the Discord. Yes, of course. Yeah, if you want to join our Discord, if you go to the website actualofficehours.com and click join our Discord, that'll get you into the Discord, and it'll take you immediately actually to that channel, to the homework help channel. Oh, okay, got you. No, you're good. You're good. Okay, cool. Fun question. Let's keep moving though, because we got 13 questions in the queue. It's Friday night. I'm supposed to go see a friend, but I guess y'all are my friends today. Let's see, Nathan. Okay. Thank you, Jamie. Appreciate it, dude. Also, if you want to help out with these types of questions, please, please, please. We're always looking for volunteers and other like smart people who want to help make a difference in the world to students who don't have access to expensive tutors. So I would love for you to join our Discord and sign up as an assistant educator when you go through the whole onboarding process. And what we do is we periodically will promote people who are helpful and like look like they know their shit to be like a special role in our community, which we call the actual educators. And I kind of call upon those people anytime there's questions I can't really do. You'd love to help out? I'd love to have you, Jamie. Please join our Discord. You'll find there's a lot of really cool, smart people, a lot of students who ask a lot of questions, and we just, we get through it. So I'd appreciate it, Jamie. All right, consider the transformation x is equal to v e to the u and y equals v e to the minus u. Interesting. Determine the Jacobian determinant, sometimes written as dx. Determine that. Okay, great. What's up, yay? You already know the answer? It's not working. Wait, right here? Make sure you do it on, if you try to do this on like a desktop. Sometimes it doesn't work on mobile for whatever reason. It should work on like a laptop or like mobile browsers, especially if you're not from the US, are like being weird. Integrals are my thing. Just put the endpoints. Well, here, let me do the Jacobian first, because I think I have to transform this and then evaluate it. This is very similar, actually, to the other question we did back here. Yeah, this question. Also, read on. Let me know if the Discord link still doesn't work. I can't post links in TikTok. It's super annoying. But maybe the link in my bio should maybe work too as well. I forget. Okay. Jacobian. I remember what the Jacobian is. Something like all the it's all like the derivatives or something. Yeah, this is what it is. Wait, where's like? There we go. This is what I want. Yes, it's the matrices of partials. I just forget what the order is. Okay. So that's dx du dx dv, and then it's dy du dy dv. I think. Again, this is very similar to what we did earlier. Oh, thanks for the diamond, Jerry.
Oh, yeah.
Larry. It says you're unable to accept the invite. And join the Discord. What? One sec. That should work. One sec. Let me make sure he can get in. What's another way maybe to, because we're a community server, so we're very, you can actually literally just look us up, I think. Let me think. Actual Discord, actual education Discord. Yeah, here you go. So if you go to here, so here, just go to Google, type in actual education Discord. We are a public server. So I think if you click on any of these links, or here, under Discord servers, under discordservers.com, discord.com/server/education, I think if you just type in like actual, we should be like the first one that comes up. Actual education, maybe. No? What the fuck? Oh, man. Wait, why do we not pop up? We should pop up, dude. What the hell? If that works, yeah. All these invites should work. Just type in actual education Discord on Google. One of those invites should work. I'm curious why it's not working on yours, because we did have people just join today. Okay, one sec. Yeah. Let me know, Jamie, if you can get any of those to work. If not, we'll figure out something. I can send you a DM or something, maybe. Or I can, like, invite you manually by your Discord username. Alright. Alright, so let's get all the partials. X is equal to v e to the u. So dx du is just equal to v e to the u. Made it in, nice. Thanks, Jamie. Glad it worked. Alright, dx dv is just equal to e to the u, right? Y was equal to v e to the minus u. So dy du. This is genuinely Japanese. No, it's just calculus. Dy du is equal to negative v e to the minus u. And dy dv is equal to e to the minus u. So when I plug those in, so this is cool. This is the matrix. We just did it, right? Or no, we didn't. No, it's backwards now. Fuck. All right, sorry. Or it's transposed, as I would say. V e to the u, negative v e to the minus u. No. E to the u. This is minus v e to the minus u. This is e to the minus u. Okay, so doing the determinant of that, you get v e to the u, e to the minus u. That's just going to be 1. minus minus, so plus v e to the minus u, e to the u. Again, this is also just 1. So it's just equal to 2v. Yeah, this is like Calc 3. Okay, so part A, it's equal to 2v, I guess, yeah. Okay, suppose the region R in the xy plane is defined as the region, the uv plane given by that to that. Transform the integral into uv coordinates and evaluate. Exactly, yes. Yeah, and then, yeah, this is 2v, and then you're going to write, like, du dv for your integral. Yeah. So when we do the integral, this is, du dv. This is part B here. And then dv is from 0 to 2. du is from 0 to 1. And then xy, right? Yeah, if I multiply those together, is just v squared. Nice. Right, isn't it v squared? Yeah. Sorry. So x times y is just equal to v squared e to the u. E to the minus u. This goes away. 1. So wait, it's 2v to the third. No? I think so. Okay, so du, that becomes 2uv cubed from 0 to 1. So that's 0 to 2 dv. So then that becomes 2uv to the fourth over 4 from 0 to 2. Sorry, there's no u. Sorry, wait. There's no u anymore. It's just 2. Okay, nice. So that's 2 to the 5th. 32 over 4, it's equal to 8. Yeah? We agree? I think so. Cool. Nice. Great question, Nathan. Hello, hello. How? Which part? Which part was confusing? This? This is just 2 times 2 to the 4th over 4 minus 2 times 0 to the 4th over 4. 2 to the 4th is 16 times 2 is 32 over 4, which is then just equal to 8. Oh, you got it? Cool. Nice. Yeah. Always ask me, like, if again, there is no such thing as a dumb question unless you ask me, like, what my favorite color is. But, so if anything doesn't make sense, any little, like, I'm more than happy to go through and just make sure that it clicks. Hey, Troll Cats! What's up? Hey, man, I hope your run is going good. Have a good stream. You're almost there. Thanks, man, dude. Yeah, hour 15. We're almost there. Oh, no. Calc 3. Yeah. Okay. Let me save this, then. Was this Nathan's? Whose question was this? Nathan. Nice. Good question, Nathan. We've had a lot of Calc 3 today. Who's my favorite superhero? Ooh, good question. I should have a favorite superhero, shouldn't I? I think Batman's pretty fucking dope. Mainly because he, like, doesn't have superpowers. He's just, like, a super nerd. But he's also, like, I mean, really rich. That kind of helps. I would say that the Christopher Nolan Batman movies are some of my favorite superhero films. So, probably Batman. You need help with your homework? You came to the right place, bro. Alright, let's see. Next up is Matthew. Compute the Laplace transform. Ooh. Ooh. Batman is not a superhero. Metahuman. You can text there, but your question won't get really answered because the chat goes like crazy. Your best bet to getting your question answered is to drop a screenshot in the website actualofficehours.com. This is where it's at. All right. get the queue going. Batman is a grown-ass man in a costume? Hot take, dude. But he's a superhero, dude. Is he not? He's a DC super person. I feel like he is.
Nice.
Send nudes, Mahmudo.
You done messed up, Aaron.
Salute. What's up, back up? Thanks for the follow, by the way. Salute. Did I meet you yesterday at the French thing? French meetup? It's not that. Ooh, what is it, Mudo, then? Let me get the Laplace transform table. I need a table of Laplace transforms. D's. Oh, it's D's nuts? Oh, my God. Oh, man. Got him! You did get me. You got me. What's up, Alistair? You know my government name. Giovanni, how's it going? No one calls me Gio. Or Giovanni, only my family calls me Giovanni. Not even my girlfriend calls me Giovanni. I forgot what a Laplace transform was. Yeah, it's okay. It's a way of like expressing. So this is cool. If you want to like draw like what this, we're basically family now. Are we, Alistair? What do you get me for Christmas, Alistair? So this is kind of a weird like piecewise function, right? So f of t is equal to 1 from, so let's say this is t and this is f of t. I'll just show you like why we use it. So I have to integrate that from 0 to 1. So from 1 it's equal to this, right? And then it's equal to t from 1 to 2, right? So that means it does like this. And then it's equal to t squared for anything greater than 2. So I don't know, it's like fucking going crazy. You're getting a rocket science chat GPT problem? Are you? Are you gonna do that to me? Don't do it to me, dude. Alistair, please.
Huh?
Be nice. Be nice, dude. Okay, so that's what we get, right? And then this is, we want to express this in Laplace place, right? Well, okay, Laplace transform. So big F of t. It's not exponential? Isn't it t squared? That's pretty exponential. When we transform it to capital F, you're right. That will not be exponential. Oh, okay. Sorry, not exponential. It's quadratic. Thank you. Yes, no, you're right. You guys are right. You guys are right. I made a mistake. Happens sometimes. I'm currently stuck on a Galerkin truncation of a 1D partial differential equation. You want to do it for me? I don't think so. Really don't. Really don't, man. So, am I supposed to do the integrals, though, of this, maybe? Because there's something weird with the shift, right? I gotta do some weird shit with the shift. I'm pretty sure. Right, it's pretty easy for just the... For this one, for 1. Okay. That's, yeah, if my function is just that, it's just 1 over s. Right? From 0 to 1? Yeah. What's the shift? Because, so this table, by the way, comes from doing integrals, I'm pretty sure. But, so my question to Matthew would be, are you allowed to use the tables, or do we have to do it in, like, integral form? Yo, what's up, Destiny?
Good job.
What's crack-a-lackin', dude? How's college? Or nursing school? I forget, wait, which one are you in? You're in one of those. Nursing school! You must be done coming up soon, no? Yeah, it has been such a long time, dude. When do you graduate, Destiny? Sorry, I have Destiny in the chat here. 2028. Oh, we'll see. Oh, so this is your second year then? I remember talking to you when you were definitely in your first year, and that was like a year ago. Oh, okay. Third year. Oh, wow. Okay, cool. Yeah, never worry about like how long it takes, dude. My PhD took me 9 years. The important thing is to not give up. It's about the struggle is like kind of the half the fun of the journey, honestly. Why did it take me... My PhD's in plasma physics. Yeah. Why did it take me 9 years? My project got shifted. Like, it got switched. So, like, 4 years into my PhD, my project got switched. And then, when it was switched, about 3 years into that, the theorist I was working with, like, fucked up. So then I had to go develop a theory to explain my results. So it was a couple, like, you know, hiccups, as we say. Yeah, get it right, dude. Yeah. Don't fail your classes. Don't do that. Whatever you got to do to lock in, get the Anki, dude. All the med students love the Ankis. I did like shear flow plasmas and stuff. I just want to teach classes, so I low-key want my grad degree to go slowly without making anyone mad. Also, like, I wasn't in any hurry, dude. I was having a great time as a PhD student. You get to travel. Like, no one, like, complains about you, like, taking time off. You're just like, well, okay, he's working on his PhD. Like, no one judges you. It's actually quite nice. I honestly, I didn't want to leave my PhD program because then I didn't have to answer the question of, like, what was I doing with my life? Because as long as you just tell people, like, you're working on your PhD, they're like... Nice, good job. Yeah, keep working on it. I'm like, okay, cool. If I just keep working on it, then like no one will like say what else are you doing? Good. Well, I'm glad, Destiny. Yeah, you figured out. Yeah, it's like calibrate, adjust, figure out what to do better next time, and just keep trying. If it's not for lack of effort, then yeah, it's all part of the learning experience. Can you do a lesson on integrals? I don't really do lessons on this stream just because there's so many people asking questions. Zach does lessons. Zach's another great streamer. Make sure you go follow Zach. Zach's great. It was fun, Jorgen. Like, I didn't complain. Like, I was having a great time. Towards, like, year 8 and year 9, I was kind of fucking over it. But that was also during COVID. So it's not like I could really go anywhere anyways. So I was like, okay, we'll just... They keep paying me, so I don't really want to leave. Why did I finish? I eventually... came to the point where it was like I was done being a grad student and I wanted my PhD and I wanted to go do this. Like, this was starting to like to really call to me to do education and stuff, and so I wanted to be relieved of you got to close the loops on things. The PhD thing was a huge like loop of my life. It was a nice chapter, but you got to close the chapter. I have been a physics professor. I'm 35. I have been a physics professor, actually, Destiny. I taught physics at UCLA in the spring quarter, and I taught it over the summer. And yes, because I have a PhD, that's why I can teach at UCLA. That's why I have done it. Nice. And yeah, if you need help with calc, Destiny, I got you, dude. We do a lot of calc here. I was not paid very much in my university. I think we got maybe like $35K a year, which is fucking trash. I mean, you did get healthcare at least. Healthcare is expensive. But also, I tutored a lot on the side, which is actually kind of how this developed. Is because I wasn't paid very much as a grad student, I had to do side work to also like fund my living experience. I mean, I guess if I just ate ramen and lived with like the barest of means, I could have done it. But I wanted to enjoy life, especially in your 20s. Like enjoy life. You only get that body like once. And so I picked up tutoring, and that's when people ask me like, how do you know how to teach all these things? It's because I fucking tutored everything. Anytime someone needed anything, I took it on. I didn't care if I didn't even really know it. I figured it out and then I taught it. Yeah. Thank you, math tutor. What's up, 1K? Good to see you. Yes. You want to come say something, Destiny? You can come say some stuff if you want. Here, I'll invite you up and come to the stage. Yes. What's up, dude?
Hello. Oh my gosh, it has been so long.
Oh wait, I haven't had someone. I haven't had someone like actually on my stream in like a while. There you are. What's up, Destiny, dude?
Dude?
There you go. Are you still in your college dorm? Is this still your college dorm?
I am. Nah, it's different dorm, but awesome dorm. Hang on, wait. You can't really see me very well on the stream. I'm trying to hang on.
There you go.
A big room this time. I got my other room this time. My keyboard.
Hey, the piano! You're doing music production, right? Don't you do a little bit of music production?
Yeah, a little bit. I'm working on a game for my buddy right now. I'm taking a little piano class. I'm working on his game, so we got a lot of stuff going on.
Sick. Yeah. Always be involved in like as many like fun extracurriculars and clubs and whatever friendship building activities. Those are always awesome in college.
Oh, for sure. Yeah.
It's a very unique time in your life.
A friend of mine from sorry, what?
I said it's a very unique time in your life.
Oh yeah, man, totally. I'm taking not taking any nursing classes right now. I'm like behind here because they're making me take the class.
Okay.
So I'm taking a bunch of like public health courses and like history and stuff.
That's cool.
And that has been so much fun. It's what I like to call my business major semester. I can just kind of chill out for once. And I've just been like rock climbing like an animal. We've been
fuck yeah.
We've been driving out to Pennsylvania and just fucking climbing 100-foot cliffs. Me and this buddy of mine. It's been
That's super dope. Yeah, to speak to things like burnout is definitely fucking real. So yeah, if you're doing exactly the right thing, because you've probably been on like go mode all the way like since high school, right? It's like go, and then eventually you're like, fuck, literally. Dude, I need a break.
Yeah.
So I'm glad you're getting that.
It's like the first time I'm like slowing down in like 4 years.
Yes.
So
it's a marathon, not a sprint. I was saying that actually to some girls last night I was out with. They kept taking tequila shots, and I was like, here, you need to drink water. I was like, it's a marathon, not a sprint. You're gonna be puking by midnight if you don't like drink some fucking water. So this is your drinking water semester. That's nice.
Oh yeah, no, actually it's funny because I just turned 21.
Oh nice.
But I have not. No, I have this whole stockpile that I bought on my birthday that I've like barely touched, man.
Well, I mean, celebrate when you're done with finals, you know.
Oh yeah, definitely. No, I'm going up to Canada once finals are over. I'm gonna be up there for a few days. It'll be nice. So I'm just I'm in an in-between state right now. I'm doing some research stuff with one of my professors. It's what I was doing this summer. And I'm still involved in the department and everything. So it's good. It's just gonna take me a little while.
It's all good. It's I always say not everyone's path is like exactly like straight. Sometimes it goes left, sometimes it goes right. But the important thing is that it goes forward. So you're still going forward.
True. Indeed. I think I want to do like research stuff as far as it concerns public health, and I think my nursing degree might help me with that. I'm not sure.
Yeah. You don't have to be a nurse with your nursing degree. Like, so this is the whole reason when I got my PhD, like towards the end of my PhD, I realized I don't want to do physics research. And that's totally fine because having the degree still allows me to have opportunities to do other things. Like, for instance, teaching at UCLA. So if you don't want to be a nurse, that's totally cool. Still finish out, get the degree, because that'll then enable you to like do other nursing adjacent things.
Oh yeah, totally. No, I'm excited for it. It's just I figured out that I don't really love like the hospital. So
that's fine.
But they are training me for the hospital, so I've got to get really good at hospital stuff.
Yes.
Which kind of sucks because it's like 3 years is like I know it's not a long time, but like I'm 21 years old. 3 years feels like a long time. So it's like, I've got to do this and train, spend the next 3 years of my life training for something I don't even really want to do, and then use that degree in other places. It's a very weird, crooked path.
No, bro. I was totally at it as well. I had that as again, towards the end of my PhD, I was like, man, I have to go do theory. I fucking hate theory. I never want to do theory, but I have to do it in order to get this piece of paper that I'm not going to use to do research anymore. But so you're in a similar position, but just, grit your teeth, whatever the fuck, bear it, get that piece of paper, then do whatever you want to do afterwards.
Completely. Yeah, no, I mean, and it's nice to be here for the moment.
Hell yeah.
I do enjoy college, nursing school. I'm at the best nursing school in New Jersey.
Good.
So it's like tough.
Congrats, dude.
So I'm really wondering, like, if I don't want to do like hospital shit, should I even like suffer this hard? Like, I don't even.
Yes. It's always worth it. It's worth the suffering, dude.
Okay. All right. Good.
You got it, dude. Fucking lock in.
Hold on to that. And that will,
yes.
That will.
Don't give up. Never give up. Never give up. Don't quit.
No, it's not giving up. It's like I'm just wondering if should I put all this into it if it's not really what I want? Like, I don't even know.
I think it comes into like the value of the degree. So like, what are your options? So this is college, right? So can you exit with a bachelor's in something, or you have to get a BSN?
BSN is a bachelor's.
Yeah, it's a bachelor's of science in nursing. But like, is there another?
Right.
Like, have you taken enough things such that you could still exit with a bachelor's in something else without having to do the clinical?
I could technically do public health, but an undergraduate public health degree is kind of fucking useless.
Okay.
It's just like it doesn't really make sense. Like
it's kind of like the same thing. Yeah, I get it. You can't really like do much with that degree.
I might be able to get out with something in like biology, but like
no, it's also useless.
Is it really?
Dude, the amount of like unemployed biology majors is just like
surprise, motherfucker.
It's really bad.
Oh no.
I would get the I would get the BSN just for job security, because if the one thing that like AI will not replace is nursing, you should just have that in your back pocket. You don't necessarily have to do clinical stuff as a nursing job later. You can be like, I don't know, some sort of like, head of whatever the fuck, IT or something, but as long as you have the nursing degree, you're like accredited within the field to do things.
Yeah, no, and I can go through and sell medical technology and be like, I used this back in the day,
yes.
Whatever.
Yes, exactly.
Do whatever.
Yeah.
I mean, it's just, oh god, it's a grind, man, just to have that little adjacent. I wish that there was like a nursing degree that I could get, be like, you're not going to be in the hospital. I wish I could do that. That would be great. Can't do that, unfortunately.
That's okay. All right, we'll play the game.
That's cool.
You got it. I'm gonna get work on this question, but yeah, love you, dude. You're great. Always.
Thank you for being for me, by the way, all these years. You've been this like quiet presence in like the back of my life since I took AP Physics. I really appreciate you, man. You're really awesome. I'm so glad you're doing this. Thank you for helping people do math, and I'm gonna be calling on you next semester. So.
Hit me up. I'll help you out in calc, dude. I got you, bro.
That's dope.
Thank you for doing what you do. Bye.
All right, peace, dude. All right, nice. I always love hearing from my previous students or current students. Everyone's like lifelong learners. All right, let's do this. Let's do this fucking Laplace transform. What did someone say here? You have a single Laplace transform for all three pieces. It is. Yes. What's up, phenomenon? All right. I'm gonna do this in Heaviside form, I think. Right? Like, I basically like shift where this shit is. So I know this, right, is the same thing as just 1 over s. Oh wait, no. This is... Oh, I think I know how to do this. Okay, wait. You solved it, Mach? Wait, which one did you solve, Mach? Are you talking about the tangent lines one? Okay. I think how you do like to do a shift... Oh, nice. Okay. I know what you're talking about, Machka. I'll check it out. So to do a shift, I think you have to end up saying like where it starts, but like it's like let me come up with it. One sec. Heaviside shifting theorem. This is what I want. Yes. Where's someone just like describing it, how it works? How big is the queue? It's 13 questions. It's pretty long right now. Sorry. We got a busy Friday. Okay, this is kind of what I think it is, right? like this. Yeah, you have to do f of like t minus a, h t minus a. So this just becomes 1 because that's fine. That's not shifted at all. And then it's plus. This would be t, but it's shifted over to the right by 1. So this is t minus 1. And then this is, I think, ut minus 1. This is like the shifter. Uh-huh. What's up, AFG? Where do you want to come to the stage? Do you have the answer to this one, AFG? Do you know how to do this? Yes? Okay, cool. You can come to the stage. What's up, AFG?
So I was like thinking, cause, wait. So what you're doing is correct. Wait, can I do it in my notebook real quick and see? Is it?
Yeah.
Let me try it real quick. I
Okay.
think I know how to.
Okay, go try it out. I'm curious. I should know how to do this. I think there's a way to do it with shifts. Who asked this? This is Matthew. Matthew asked this question. Upper limit is 1, bottom is 0. Or we could just use the definition of a Laplace transform. Sure. Is that the integral definition of a Laplace transform?
So Gold, I think my approach, so the Laplace transform of a piecewise function is the integral of f of t. I think e to the negative st, right?
Yes.
So it's the lower limit is 0 and the upper limit is infinity. So
okay.
So since it's the piecewise, you can break it.
Oh, into like all these different parts.
Yeah, into like 3 integrals.
All right, so this is 1 e to the minus st dt,
yeah. And
plus
then 2 1.
1 to 2, right? 1 to 2.
Yeah,
t
1 to 2.
e to the minus st dt. Yeah.
Yeah.
And then plus t squared from 2 to infinity, right?
Yeah.
Okay, we're not gonna use the tables. Fuck the tables. I thought the tables would be cool, but I think there's some weird shit with this shifting stuff I gotta do.
How I first thought. I mean, like, there has to be like an easier and shorter way. I mean, but
yeah. Okay.
Yeah.
But once you get to here, these are not trivial integrals, though. I mean, this one isn't. This one's a trivial integral, right? This is just negative 1 over s e to the negative st, right? From 0 to 1.
Negative 1
Oh,
over
do I have
s.
to do integration by parts for all these?
Yeah. So for the first one, it would be negative 1 over s e to the negative s plus 1 over s, I think. Yeah, plus 1 over s.
Yes. Yeah, because when I plug in 1, I just get negative e to the negative t over s. And then when I plug in 0, minus, so then that's plus 1 over s. Yeah.
Yeah. So then
okay. That one's easy.
when you evaluate it,
I could just write this as 1 over s. 1 minus e to the minus t.
1 to the e to the minus s.
E to minus s. Yes. You're right. Sorry, I plug in 1 for t.
Yeah. And then second one, you also do integration by parts.
Okay. Yeah, this is, what is this? U is equal to t, du is equal to dt.
Yeah.
Oh man, this is such a pain. I can't do this in my head either, dude. dv is equal to...
I did the first one in my head. I can't do this one, though.
No, this one is hard. And then this is equal to negative 1 over s.
E to the negative st.
E to the negative st.
Yeah. Yeah, I'm not... Oh my god.
Okay, so then it's uv.
Okay.
So that's negative t over s, e to the negative st, from 1 to 2, minus the integral, so plus 1 over s, e to the negative st,
e to the negative dt.
dt. Right?
So then that would equal negative t over s e to the negative st minus, what is that, 1 over s squared.
Yeah, it's
e
1 over
to
s
the
squared.
negative st.
Yeah, this is 1 over s squared. Or, sorry, this is minus 1 over s squared.
Yeah, minus 1 over s squared. E to the negative st, yeah.
From 1 to 2. Oh,
Yeah.
it's kind of close almost, right? Wait. So, wait. This is the same fucking thing, right? So I could say this is this.
It would be when you, because you said...
Could I say negative t over s minus 1 over s squared, and then it's times this thing, which is e to the negative 2s minus e to the negative s?
So wait, evaluate that. You should... What do you get when you evaluate it? Because I wrote it as, like, I wrote the integral as, like, a negative t over s, e to the negative
Oh,
st.
wait. I forgot the 2 here. I forgot the 2. Oh, wait. I fucked up.
Yeah. And
I fucked up. Sorry. Yeah, I forgot
yeah.
t is still in there. Damn it.
Yeah.
Okay, sorry. I thought I was being clever for a second. Okay. Negative 2 over s, e to the... Chat is dead. What's up, Legendary? Chat's probably scared from this question. E to the negative 2. And then minus, so it's plus 1 over s, e to the negative s.
Wait, what?
And then it's minus this, so minus 1 over s squared, e to the negative 2s, minus, so plus. What's up?
What up? Wait, my brain's like not working. Wait, is that what did you do? Is that the final answer, or?
Yeah. Well, no. This is from doing the integration by parts from the second part here.
Oh, because when I did the integration, yeah. Okay, so.
So I get negative 2 over s minus 1 over s squared, all times e to the negative 2s, and then plus.
Yeah, makes sense. So
1 over s plus 1 over s squared, e to the negative s. It is just integration by parts. It's just a pain in the ass, Alistair, isn't it?
I wrote it in a different form. I wrote it as like e to the negative s over s. Like e to the negative s over s plus e to the negative s over s squared minus 2e to the negative 2s over s minus e to the negative 2s over s squared. That's how I wrote it.
You can group it by you can group it by this. It's just kind of like nicer.
Okay, the third integral.
But then this is double integration by parts.
Oh shit, not good.
Fuck, dude. What? Get the fuck out of here.
Wait,
dude.
you can... Well, yeah.
Yeah.
I mean...
Well, yeah. Dude, this sucks.
The transform of t squared is what? 2 over s cubed, right?
Remember the plus c? No, there is no plus c. Yeah, tabular would be great.
Remember the plus c.
Fuck you, dude. What? There's no fucking plus c here, dude. There's things on the integral.
Oh god.
Okay.
Wait, the transform of t squared.
Yeah.
Why are you doing it by parts? Just do the transformations.
What do you mean the transformations? You want me to just integrate this? What's the transformation?
Yeah, like you know the transform of t squared, right?
Yeah, it's
2 over s cubed, if I'm not wrong. I don't know.
Where is it?
Make sure.
Oh, here it is. T to the n.
T to the yeah, exactly. See, t to the
n
t squared
is oh. Wait, but does the 2 to infinity fuck with it though?
I mean, not right now, because then you first integrate it and then you take the limit. You know, like.
Okay.
You get what I'm saying?
I think I get what you're saying. So wait one sec. All right. Let's not do double integration by parts because that looks like it sucks.
Yeah. It's a crash out there.
I don't want to crash out. So yeah, t to the n. So this is the same thing as 2 factorial over s to the n plus 1. So s to the third, right?
Yeah, because the Laplace transform of
but I think it's I think it's a bunch of them. Where are we in the queue?
2 over s cubed. 2 factorial is just 2.
Yeah. Okay, but what about the 2 to infinity though? Yeah, you have to deal with the initial condition. Yeah.
Wait.
Or, Hummy says, or, you can say, what can we say? What can we say, Hummy? It's 2 heaviside. Sure. Okay.
Heaviside?
Yeah, heaviside is this thing I was talking about over this.
Oh.
So this is if you have the function shifted over. In this case, it's shifted over by 2.
Yeah.
So this would be
2, yeah.
this would be e to the negative 2s times 2 factorial over s to the third, right?
Yeah. Okay.
Hey, Alistair, be nice. Hummy's trying. I think Hummy's onto the right thing.
So then you can write it as you can write the integral as e to the negative 2s. Right? E to the negative 2s integral t plus 2 squared e to the negative st dt. Give it a write down and show you.
Sorry, say it again. Sorry, e to the negative 2s.
E to the negative 2s, then the integral sign of 0 to infinity, because you shifted the lower limit by 2,
okay,
right?
got you, yep.
And you get t plus 2 squared, like the whole quantity squared.
Okay.
Wait, e to the negative st dt. Yeah, I feel like... And then you expand t plus 2 squared.
I'm still gonna get a t squared though, right?
Yeah, of course. I mean,
not e to the neg. Is it e to the negative st?
I mean, I think so. No.
Okay, no. I think we're good. All right, okay. So we think e to the negative 2s integral from 0 to infinity. So then that's t squared plus 4t plus 4 e to the negative st.
Yeah,
dt. And then
you can use the transforms.
Okay. Now I know the transforms.
You have t squared t squared e integral of t squared e to the negative st.
Negative st. That's just this. That's 2 over s cubed. Oh, very cool. I like this. Okay, this is where we're using the tables. Okay, and then this is 4 over t. So this is plus 4 times t, which is then just 1 over s squared. Yeah. Oh, so 4 over s squared, right? Good. And then plus 4 is just plus 4 over s.
Good job.
Oh shit! And then all of this is times e to the negative 2s.
Yeah. Now you just add them all.
Okay. Now we just add them all together. Okay. So we have 1 over s, 1 minus e to the negative s.
Yeah.
Plus, I'm gonna copy paste some shit. This plus this. Cool. I think that's it. That looks pretty good. Let's see. Actually, 1 second. Let me throw this in the chat.
I mean, this is simplify it. No.
Well, let's see. I want to see what chat got. I think we're pretty close actually to what chat got.
Chat? Who's chat? Oh, ChatGPT.
ChatGPT. Yeah, my friend Chat. My friend ChatGPT. All right, here we go. ChatGPT. Let's see. All right.
Whoa. Did it use like heaviside or what is this?
Yeah, I think it did use heaviside. This, right? This is here. This is here with the minus signs distributed. Good. 4 over s squared, 2 over s cubed. Nice. We did it. Good job, AFG.
I forgot all this.
No, that's cool, AFG. When did you learn this, by the way? I'll give you a bonk coin for this. This is dope.
Oh wait. I'll show you.
Where did you learn how to do that stuff? That's pretty cool.
All this math?
Well, where did you do Laplace transforms? Like what class?
Oh, I didn't take a class.
Oh, you just went at this on your own? You're just like, I'm just gonna like fuck around with it?
Yeah, I self-studied it.
Oh, wait, sick, dude.
Look at this link.
Okay, you send me a link. All right, let me see.
This guy, 3+1 pound. I love him. It's like he has a multiple, a lot of videos on Laplace transforms.
Oh, this is dope.
And, yeah, if anyone, I mean, this book, I like this book too. It's like
3 blue 1 brown is they use this is all Manum. All this coding here, this visual coding is all done in Manum, which is like super dope, super cool.
It's so good for understanding though, like
it is. Yeah, no, super cool. They must have some really good developers on their team. I mean, they are an 8 million subscriber YouTube channel. You have a book you like to use though, AFG?
Yeah, I got a book. Like, I mainly use this most of my time. I mean, when I'm still a junior. I mean,
that's crazy. You're junior in high school and you already know how to do Laplace transforms.
Yeah, I mean, it's just like I tried, and I mean, because I make AI and stuff, so I need it.
Yeah, he's like, I make AI, so I do need it. That's cool, dude.
Yeah.
Oh,
like,
nice, Machka. I'll check it.
Helped me till like Calc 3. This book.
Okay.
Pretty good.
Let's see. Calculus with analytic geometry.
It's a good book.
Wow. Okay. Straight from Archive. I love Archive.
It's like it goes up till like what it's called.
So this is like this is a calculus textbook that also goes up to like analytic geometry.
Yeah, it goes up to like Calc 3 up.
Very cool. Oh, here. I can see the. Okay.
Oh yeah, yes.
Derivative, yeah. Integrals, applications, trig functions. Sick. Power series, conic, polar. Yep. Oh yeah, this is
multivariable for sure. Nice, good job, Alistair. Three brown, 1 blue is the guy who made. Oh, he created Manum? Oh, I didn't know that. Ahmed, that's cool, dude. Oh, that would make more sense with why he's so fucking godlike at it.
What's Manum?
Manum is the programming language they use to make those animations.
Oh.
I've used it before.
You can actually get ChatGPT to write Manum code. Yeah, it's pretty cool.
Oh.
Nice. Okay. What's up, Alistair? Yeah, I do need to drink water. Thank you, Alistair. That's really cool. AFG, what do you do? What do you make with AIs? What do you make? What's your thing?
Right now, I'm designing. Let me read it off my description.
Read off the description.
Yes. It's okay. Let me see. This is my GitHub description.
Oh, okay. Git's great. Oh wow, Machka did a beautiful solution for this question.
Yeah, I'm making a multimodal language.
Multimodal, right? Which means it takes in a bunch of different like it can do image processing, it can do like text processing.
Yeah, exactly. It's to support text generation, 2D image processing, 2D image processing and generation, 3D video analysis, 3D video generation, audio understanding generation, and more. It's in beta right now, so.
Okay. You want to send your Git link? Send your Git link. I'll check it out.
It's private.
Oh, okay. All right, you guys. All right, I see. Send me your link when it's public. Send me your link when it's public.
Yes, I got you.
Okay, you're good. Yeah, don't give me your trade secrets. All right, cool. Good shit, AFG.
Yes, thank you.
No, thank you, dude. All right, sick. Machka, this is a cool solution, by the way. I like that you did this. Let's see.
What is that?
So this was the question originally was like find a function for which all the normal lines of f of x equals x squared are tangent lines. So they graphed f of x. They graphed x squared. I love that you did this with Desmos, by the way, Machka. This is really pretty. And then the red lines here are all the normal lines. This is when x is less than 0. This x is greater than 0. Very cool. So we want. Oh, and I see there's different regions. Okay. Okay, we want to find the values of x and y such that the two... Okay. Wait. Number of normal lines. But the lines like intersect sometimes. Oh, I see what they're doing here actually. We want to find the values of x and y such that the two normal lines of x squared intersect. So this equation solves for all values of x in which they share a normal line with a given point x1, y1.
Yeah, see, I could never do these type of problems. Like
It's fun. It's a fun little puzzle.
Yeah, I know.
Okay, let me try to understand this. Sorry. Yes, because 1 over f prime of x. This is the equation for a perpendicular line. It's just the negative reciprocal. That needs to equal to f of x minus y1. Okay. Oh, I see, because this would be the slope. Or I see this. Oh, this is very cool. This is what the slope would be of the line, of the normal line with the point x1, y1. Because you're doing y2 minus y1 and x2 minus x1, but like in this case, y2 is f of x and x2 is x. Okay. And so, wait, so cross multiply, wait. F prime of x was equal to 1 over 2x. Oh, I see. So you multiply that. Cool. You multiply that. And now you get this. Divide by 2 to make it a cubic with a equals 1. Oh, God. Because a equals 1 and we want exactly 2 solutions, this can be factored like this. Bro, I would have never come up with this, Machka. This is crazy, dude.
Yeah, this is crazy.
This is cracked, dude. What? This is dope.
The moment I see that problem, I would have never thought of doing all of this. I would have probably like found the derivative and be done with like.
Yeah, I'd be like peace. I'm out, dog. What the fuck? This is cool though. All right. So, in terms of m and n, so 0 equals m plus. Okay, we can solve for b, c, and d in the cubic. X plus m, x plus n, x plus n. 0 equals. I don't know where this is coming from. Okay. So then we solve a system. And then you get to this. Wow. Machka, I'm gonna still need a little bit of time for me to like understand like what happens from here over to here. He did solve it. No, he got the right answer. And he has a beautiful solution here, actually. I just need a little bit more time to understand it. I'm getting close. I appreciate you doing this, though, Machka. And if anybody else wants to read it, it's in the Discord. Where is it? It's right here. Let me take some time to, like, read through it. I really appreciate all the effort you put into doing that. It looks sick.
Look, I put a good problem if someone like puzzle solvers want to try it. I couldn't do this. I ultimately had to ask ChatGPT.
ChatGPT. Yeah, some of the cubics. Yeah, I don't know. Like I know all the quadratic stuff, but like some of the cubic stuff, I'm just like, no.
This is some odd and even function. Like no.
Like yeah, I think this is this. Sorry, Machka said 0 from 0x squared. I think this was. Oh. I see what he's saying. See how this is x cubed? This is just a power of x, and this is like x to the 0. So in terms of like the x squared term, if you were to do this, the x squared term would be m plus 2n, but that has to be equal to 0. I see you're doing it term by term. And then 1 minus 2y over 2, that's just the x term. So that would be n squared plus 2mn. Okay. Right, because you get one. Okay. And then this term here has to be nothing. So that just has to be n times m, which is mn squared. I see it. You're doing it term by term. It's actually really smart. Okay. I do get it. This is very smart. Yeah, so let me just show real quickly what's happening here. Because this is cool. And I appreciate it. All right, good to see you. Yeah. Always hop on the Discord whenever if you want to talk or you got like some ideas or insights.
Discord, like, cause I had like I don't know 6 pings from my friend, so I was like, let me see what like everyone's.
Let's see what's going on. Fuck yeah, dude. Yeah.
And I saw Laplace, so I just had to.
Yeah, you're like, I know Laplace. Let's do it. I appreciate it, dude.
Yeah. All right. See you.
Peace, dude. All right. Yeah, so here, let me show you, Alistair was asking about this. Okay, so then this is x cubed, right? And then this is 2x, or I should say x, x squared, 2n. And then this is x n squared. And then this is x squared m. And then this is x 2mn. And then this is mn squared. Oh, how can you factor this? Oh, because this is a cubic. So cubics can be factored like this. Oh, okay. I don't know exactly. I think this I think comes from this. There's like some intuition here. Machka, if you want to like maybe tell us. But I think because a equals 1, right? That does tell you that it's always x, 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 right? There's nothing in front of these x's. And then for there to be exactly 2 solutions, that means one of the solutions has to be degenerate. So you need a copy. So that's why it's x plus n like squared. In general, like if this is a cubic and the roots, right? Solutions, yeah. Yes, so Machka said there's a singular line on the combined graph for which 2 normal lines intersect. Yeah. Yeah. Okay, so from this, so you get x cubed, and that's times 1. And then plus x squared, and then that's m plus 2n. And then plus x, and then that's n squared plus 2mn. So that's x to the first. And then it's plus x to the 0, mn squared. So then that's where you're getting all this, right? This is x to the 0, so that's this. This is x, so that's this. That's where you have n squared plus 2mn. And then 0, that is because there's no x squared, and then this is 1. Okay, cool. So when you do that, yeah, this is a systems of equations. Fascinating. You get m is equal to this, blah, blah, okay. So 1 minus 2y is equal to that, Oh, and then you're just solving for y1. How did he get from there to therein? One step, there to what? No, he's showing all his work. I agree with this. This is really cool. Yeah. This is pretty genius. This is the genius, by the way. This is the genius moment here. I really like this. This is cool. And then you're just solving for y1. Fascinating. Cool. I like it, Machka. I think it's great. I'm going to give you a coin for that because that's a really cool question you did. Machka, what's your background? Are you a student, grad student, just math lover, or what? It's a really cool solution. You're a junior in high school. How do I have so many smart motherfuckers that are in high school? This is dope.
That's dope.
Y'all are awesome. Yeah, you and like AFG, like doing Laplace transforms, very cool. I appreciate it. Yeah, thank you for... I will say, so for those, you young people who are very smart in math, I would definitely stick around the Discord because I have some potential partnerships opening up with... I can't really say a lot about it because I had to sign some NDAs for it. But let's just say it involves like very smart young people and they're trying to recruit these people for things. So when I can tell you about it, which I hope is in like a couple months or something, I would love to tell you guys about it, I guess. Yes. You would be the ideal audience for it. It's a lot of stuff with like some very cool people at like XAI and ChatGPT and stuff. Can a 6th grader apply? Yeah, I think it's kind of like all ages. You just have to have there are certain people that just, for whatever reason, have a real knack for doing these high-level math things at a very young age. It's very impressive. And this is kind of like a program to like kind of accelerate those people doing more things. I'm sorry, I have to be so vague with it because I don't know exactly what I can say about it. But I'm glad you found us. I think that's kind of the main thing I want to say. And then, yeah, stick around. Okay. It would be online as well, I think. For the state table and each of the state assignments shown, design a system using D flip-flops. Okay. This is a circuits dude, I hate that I'm on the precipice of this. I like almost know how to do these questions. Because I feel like this is like input, output. Awesome. Yeah, that's your dream job? That's really cool, Machko. I'm glad. Well, so some of the people in our Discord are math professors. I've been a physics professor, so you're definitely around the right people. Just keep doing what you're doing, and the right opportunities will like materialize, and then you'll be put on the path to do that stuff. This is not Algebra 1. Sorry, Arts. I can't see your chats. Sorry, my bad. The chat thing breaks sometimes. Give me a second. Yeah, fucking TikTok. Dude, no, you're fine, Arts. So I have that on another screen. Okay. TikTok's just being fucking annoying. One sec. Let me go to the standard connection. See if this works. Okay. I don't think... Again, we have 20 minutes left. I'm running out of time. I can't do this question. But someone in my Discord probably can. So I'm gonna just put this into the Discord, Jacob. I'm gonna do the same thing to clickbaits. And just mark them as unsolved. So someone else in my Discord who knows about like circuit design or like logic circuit design will probably take a stab at it. Or we have a ChatGPT bot that goes through all the questions every like after it's been 2 days. Okay, sorry, let me see other things. Sebastian, derive the integral equation to solve for the magnetic field at point P for a finite segment of current wire as depicted. This is Biot-Savart, I believe. Check the convert. Yeah, let me just go through all of them real quick. Let me just see. There are a lot of questions I got asked. Ahmed, where's it? You're the last one. Oh, this is cool. This is French. Something about determine the domain of the definition of D. Montreurs usually demonstrate that S is a class of L1 that spans D. Is that what that means in French? Okay. You know who's really good with series, Ahmed, by the way? His name is Zach. So if you go to if you go here to our website, actualofficehours.com, click on the streaming schedule. These are all the other people that stream, and they're really great. Zach, E2iPi, has a stream. He did his master's thesis on sequences and series. He has a PhD in math as well. But he has a stream Saturday morning, so in about 10 hours from now. And he would probably be the best person to go over that question. I am using a Wacom. Okay, sorry. Let me just see if there's something that, like, I can just, like, do quickly. Oh, this is a fun one, too. What do you do as a job? I do this. Han Solo and Chewbacca? Oh, this is so fun. Oh, man. I love all these questions. You guys... Oh, man. I wish I had more time tonight. Fuck. One sec. Let me see. Can I move some things today? Probably not. Okay, here we go. One sec. Okay, I do have a little bit more time here. I'll add 30 minutes to the. Let me add 30 minutes to the clock for you guys. Can I solve JEE questions? I really don't like JEE. I have kind of like a ban on JEE questions just because they hurt my soul. Okay. Okay, I'm giving you guys another hour. Look at that. I'm a kind and generous God.
Oh, yeah.
We're going 5 to 9 today. It'll update. Okay. Then let me just kind of go in order, because I feel like I can still go through some of these questions in an hour. Sebastian, you're up. Because I want to do the Chewbacca one. That one looks fun.
That's
Okay, here we go. Yeah, don't worry, Arts. Derive the integral equation for the magnetic field for the finite segment of the current carrying wire as shown below. And it goes from -a to a, right? Yeah. Dude, yeah, JEE is a nightmare, bro. It's so hard. Okay. Let's remember what, like, Biot Savart is. This derivation has been done a lot before, actually, too. Okay, so we need to integrate dB. I think we're gonna do it. So yeah, and then we got us also. This is our vector, right? Yeah. So dB is mu naught I over 4 pi, and then it's dl vector cross r vector over r to the third. They do like the unit vector here, so the best way to write the unit vector r has is to write this as like r prime over r vector over r. It's just easier because now I can describe r vector, right? So r vector always points from like where I am to where I'm measuring the magnetic field, dB. So in that case, r vector is gonna be whatever this point is. So that's gonna be x minus 0, right? X minus 0. 0 minus the y point, so 0 minus y, I guess, right? And then, oh, in z it's 0. Yeah. This is, yeah, we're trying to solve this. Okay. So, yeah, okay, so that's equal to x comma minus y comma 0. Great. And then dl is just along this direction. So dl is just equal to 0 comma isn't it just in the y direction? Yeah, it's just dy comma 0, right? Right, yeah, dl is just y, is just dy y hat. Yeah, okay. Cool. So then that cross that will give me an x and a z component, I think. No, sorry. Y cross x will give me z. Y cross y will give me 0. Yes. Okay. So this is where you could like kind of just do this in your head. IJK 0 dy 0 This is x, negative y, 0. Okay. Okay, so this is 0, right? So you have 0 in that component, 0 in this component, like I thought, right? Okay, cool. And then there's only the z component, which is just going to be x dy. Negative x dy. Beautiful. Okay, cool. Okay, so that's equal to mu naught I over 4 pi. And then we got to kind of write out what r cubed is. So r cubed, if this is r cubed is just like the third power of that. So this is the same thing as x squared plus y squared to the 3/2. And then this is all over negative x dy. And then this is in the z direction. Right, and then this came from this. Okay, cool. Now, here's the interesting thing, is that as we integrate from minus a to a, let me think. No, that's okay. You could also just do 2 times 0 to a, I'm pretty sure. But here, let's do it from 0 to a. I think you do this. So, integrating. I'm thinking of the electric charge. The electric field is interesting because you get it canceling out. It's BS of R. This is E&M physics. Yeah. Electromagnetic, whatever. Okay. And then this is... I think we also take the absolute value of this. So negative a to a. We just say it's yeah. What's up, clickbait? X dy over x squared plus y squared to the 3/2. Right. Okay. Oh, this is the integral equation. Okay. Okay, then you're done. Right? Yeah, nice. I think you can eventually show this is like sine of A or something. It's integral of that dy. Right. Oh, I see. Oh, I think I have to do trig substitution for this. Right. This is 1 plus tangent squared. Oh, man. I don't know if I want to do that. Okay, we're just going to leave it as this. This is cool. Nice. Okay. I can say, like, you could do... do... trig sub... with y is equal to x tangent theta. All right, that was Sebastian. Yeah, it's electromagnetism. Yeah, not too crazy, right? Okay, let me see. Who's next on the list? Andrew. I like the Han Solo question. This is fun. Just because it has Chewbacca in it. Han Solo and Chewbacca have attached two 1.5 meter long cannons to the Millennium Falcon with a 100 kilogram cannonball. Each has a charge of 10 coulombs. Cannon 1 uses gunpowder. Very cool. What velocity does each one... Okay, it's very cool, actually.
Good job.
Okay. Cool. So, okay. This is cool. Because you're doing mechanics and electrodynamics, I guess. Yeah. So here. So for the gunpowder... You know that v squared is equal to v naught squared plus 2a delta x. So v squared is equal to, we assume 0, plus 2 times the acceleration, which is 100. And then delta x is equal to 1.5. So that 300, v squared equals 300. So v equals the square root of 300. What's that? Square root of 300 is 17.3 meters per second. Have a good day, too, Chai. Cool. Okay, now for the electric one. This is cool. An electric field. Okay, so F is equal to QE, right? F equals to QE, which is equal to MA. So A is equal to QE over M. So this one is 10 coulombs, which is a lot of, that's a lot of coulombs. And then 100 nanocoulombs, cool. And then and it's a mass of 100 kilograms. Okay, cool. So A is just equal to 10. Yeah. So same thing. V squared is equal to 2 times 10 times 1.5. So V is equal to square root of 30. .47 meters per second. Cool. Unbeknownst to the crew, R2-G2 is performing repairs on the ship when the first cannon is fired perpendicular to the surface of the ship. R2 has a mass of 32 kilograms and a charge of minus 5 microcoulombs. If R2 is standing 5... Yeah, did you see that from Mistral? Yeah, I didn't answer it. Machka did. You talking about this one? This was very cool. Yeah, Machka did this. Machka's a junior in high school. So many smart kids. I'm always impressed. Yep, it's over. What was the question, Dream of Dawn? So why is my... they need to fix... The chat integration with TikTok's always messing up, dude. It's super annoying. Oh, there you go. Now it's working again. Yeah, go check it out for Mistral. Yeah, it's in the Discord. The solution's there. Okay, B's a little more tricky, though. Okay. So I think we're just doing F equals KQQ over R squared. So in this case, that's 9 times 10 to the 9th. And then Q of the cannonball is 10. And then Q of R2 is 5 times 10 to the minus 6. Not very charged, R2. And then R squared is equal to, if he's at the base of the cannon, then R is 1.5. I'll take a look at it right after this, yeah. See what we get here. Okay, pull calculator out. So 9e to the 9 times 10 times 5 e to the minus 6 divided by 1.5 squared is a lot. Oh shit. Oh, that's a lot. 200,000 newtons? 2 million? No, 200,000. Wow. 200 kilonewtons, yeah. Dude, but R2 can only use 320 newtons. He can only use 320 newtons to hold him on to. So yeah, he's definitely pulled. Charge is cracked. Yeah, it is. Dude, that's why I said, like, 10 coulombs is a lot of fucking charge. Yeah, so poor R2. Okay. Which is much bigger than 300. What was it, 320? Yeah, 320 newtons. He flows away. All right, cool question, Andrew. It's because of that K constant is so big, dude. 9 times 10 to the 9th is huge. Damn, boy, shit thick. All right, let's see. We got Mia. This is kind of like some more like fun, like theoretical questions, I guess. What is Coulomb's law? Coulomb's law is this, right? F is equal to 1 over 4 pi epsilon naught Q1 Q2 over R squared. And it's the force exerted between point charges having charge Q1 and Q2. What is electric field and how does it relate? So F, which is, so F, Coulomb force, we can say FC, is equal to QE. What is it physically, though? I actually don't know. Like, what is an electric field? Yeah, okay, there we go. Between stationary. You're right, they do need to be stationary. I don't know really how to describe what physically an electric field is. I just know they're created from point charges. Yes. That's right, Jorgen, right? Yeah, what is a dangerous question. Yeah, because it's like, what level? This is probably being asked in like a 9th or 10th grade, like, you know, high school class. So I doubt they're using the word vector field. I don't know. I'm just saying, like, yeah, it describes how charges would move. Okay. What is the physical significance of the permittivity of the material? Okay, so now this is getting more advanced. Sorry. Is that epsilon not permittivity? What's up, famished? I would hold off on giving definitive answers to the what is questions for a few centuries. Yeah. So, yeah, what is the physical? How an electric field interacts with the material. Oh, how an electric field is permitted to form within a material. That's cool. I like this. These are all great answers. Thank you, ChatGPT. Or Gemini in this case. Yeah. I didn't ever think of it that way. But yeah. How was it derived? Ooh. Did it come from Gauss's law? Do we think it came from Gauss's law? Torsion balance was used to solve. Yeah. Or is this, sorry, is this Millikan's oil drop experiment or something? It was torsion balance. Very cool. Okay, cool. Cool. And what is the principle of charge conservation? Oh, I guess like charge can never be created or destroyed. Kind of like mass conservation, right? Cool. All right, cool. Good question. Mia.
Well done. Well done.
All right, let's see what else. What else we got? Joel, use calculus to find this. I think this will be a fun one, actually. This is actually kind of a nice little smooth jazz. Because the nice thing is, I think I can just write these as two different integrals, right? I can just say this is the integral from 4 to 9 of x squared over the square root of x plus the integral from 4 to 9 of 1 over the square root of x. And let's remember the square root of x is equal to x to the 1/2. So this is the integral. Oh, don't forget the dx. 4 to 9 of x to the 2 minus x to the 1/2. So that's x to the 3/2. Plus 4 to 9. And then this is x to the minus 1/2. And now this is just power rule. Take this, raise it by 1, divide by the new one. So that's going to be 2/5 x to the 5/2, evaluated from 4 to 9, plus 2 over 1 x to the positive 1/2 from 4 to 9. Because minus 1/2 plus 1 gets you positive 1/2. And then when you divide by positive 1/2, it's the same as multiplying by 2. Sick. Okay, so now we can just solve this. So that's 2/5. And we can say, like, the square root of 9 to the 5th minus the square root of 4 to the 5th. plus 2. And then this is square root of 9 minus square root of 4. Yes, this was really nice. It's nice to get nice questions, though, sometimes, right? So it's 2/5. 3 to the 5th minus 2 to the 5th plus 2. 3 minus 2. I'll take them, though, dude. I fucking love them. What is that, though? That's not 243, right? 3 to the 4th. No, it is 243, right? Are we... back up. Do you do this a different way? I'm curious. This is 32. Plus 2. Is 3 to the 5th 243? Yeah, okay. I'm not crazy. 211. Right? Plus 2. 422 over 5 plus 10 over 5. 432 over 5. And you're done. Nice. I like that one. Thank you, Jolie.
Well done.
All right. How are we doing tonight? Been going for 3 hours and 3 minutes. I do need to eat at some point. Use calculus to find this. Happy? This is from someone named Happy. This is another simple question. Maybe we're just gonna like speed run through these. I bet then I could go eat. Oh, this is integral of 2x to the 1/2 plus integral of 5x to the 1/3. Again, raise it. So I get 2 times 2/3 x to the 3/2 plus 5 times 3/4 x to the 4/3 and then plus c. This is the one time I'll agree that someone can yell at me for plus c. Okay, so that's 4/3. You could say this if you want. Cube root of x squared. No, wait, cube root of x. No, I fucked that up too. There we go. Plus 15/4. Third root of x to the 4th. Plus c. Nice.
Good job.
Wow, these have been nice. Love these. C equals 4, by the way, if you're curious. Why is C equal to 4?
Well done.
Why do you think C is equal to 4? Why is C 4? I need a... Oh, wait. Oh, because x can only be integrated from 0 to infinity? Is that what we're saying? It's science, God said so. I mean, I'll go with it. I'll roll with it. I mean, the domain of that thing is definitely from 0 to infinity. Okay, what's next? Bob. Ooh. Electric fields correspond to the acceleration of a fluid, but that does not illuminate anything. Charges respond to it with a sign difference. Yes. Are you asking about the high school question? About like what's an electric field? This is another fun one. Dude, I love who someone just dumped like a bunch of like speedrun calculus questions. Okay, I don't know what the derivative of 1 over x plus x to the 4th is. But I do know what the derivative of something. We'll get a different color. I do know the derivative of something to the fourth is, right? It's equal to 4 times that something all to the third plus ddx of the something. Yeah, we will probably get food today. I'm happy. Okay, so then if I remove the box, right, that was my 1 plus x over x. But now I need to take the derivative of this. So this ends up being negative 1 over x squared plus 1. Okay, so your final answer is this minus 1 over x squared plus 1. Beautiful. Another one. This was Bob.
Well done! Well done!
Plus 4? Wait, did I fucking forget a 4 in there? No, there's no plus 4. Where's the plus 4 coming from? I think it's just plus 1. Yeah. Is this more like God just said so? Oh, it's a joke from the integration. Yeah, I got you, bro. All right. Khaled always has some interesting ones. Yeah, here we go. All right, let's pull these in. Okay, there's some vectors. Find an equation of a line which passes through A and B. Well, that's easy. It's just vector B minus vector A, right? So AB is equal to vector B minus vector A. Khaled, not too bad, right? So this is going to be 3, comma, P, comma, wait, no. No, B's the second one, sorry. 6, comma, 2, comma, 6, minus 9, comma, minus 2, comma, K. So then the equation of the line is negative 3, 4, 6 minus K. Oofy. The model gets really absurd real fast. Oh, 9, negative 2, 1. Yeah. Sorry, I'm done. I don't know why. The K is the unit vector. Oh, no. I'm getting tired. I'm getting tired, boys. Sorry, I'm getting tired. What's happening? Did you try to rock there? Yeah. Sorry, it's not 1K. They said find the... Okay, so it's this times t plus the point, right? Which would be 9, comma, minus 2, comma, 1, right? Isn't this kind of it? That's like parameterized form. Because this is like the slope. This is a slope between 2 points and then plus like an initial point. All right, great. Given that C lies on L, find the value of P and Q. Okay, cool. So that means 3, comma, P, comma, Q has to be equal to negative 3T plus 9 comma 4t minus 2, comma 5t plus 1. Okay. Systems of equations, I guess. Yeah. So, negative 3t plus 9 equals 3. This gets me the t, which is nice, right? So t is equal to 2. And then that tells you what this is, right? P equals 4 times 2 minus 2. So that's equal to 6. Q equals 5 times 2 plus 1 equal to 11. We're doing great. Vector point D lies on AB and is such that OD is perpendicular to AB. Wait, where's O? Is O the origin? Okay. OB is perpendicular to AB. Find the possession of vector D. Okay. So OD is just equal to whatever D is, right? So this is like D1, D2, D3. And it's perpendicular to AB. So that means the dot product of... No, so the cross product of it is 0. No. Yes, the dot product of it is 0. Okay, so this dotted with negative 3, 4, comma 5 has to be equal to 0. Okay. Because this is, yeah, this is like, so yeah. So D vector dotted with AB vector has to be equal to 0. You can also assume OD is a unit vector. Okay. Well, so what do I get here? So I get negative 3 D1 plus 4 D2 plus 5 D3 is equal to 0. Oh, if I want to do like 1 over the square root of 3 or something. Well, actually, I don't know what it is. Okay. All right, this is one equation. But also I know it lies on it, right? So I also know from this, right, that D1 must be equal to negative 3t plus 9. D2 equals 4t. Right? What's up, Legendary? I love this question too. And then that D3 must equal 5t plus 1. Yeah, math is fucking dope, dude. Interesting. Well, I think we can use this, plug into this, solve for t, and then we get d's. Right? Plug and chug. There's a minus sign here. Equals 0. So 9t minus 27, right? Plus 16t minus 8 plus 25t plus 5. 9t plus 16t plus 25t is 50t. Minus 27, minus 8, minus 35. Plus 5 is minus 30. So t is equal to 3/5. Cool. It is kind of like partial fraction decomp, but not quite. This is more. Sorry, this is vectors. Yeah, what's up, fam? My arch nemesis in 16. No, you did play that well. I was looking at it. I would have had to have bet everything, and also assumed I would have gotten 4 questions right to have beaten you, which would have been a very wild bet to do. You're good, Wade. Yeah, it was very close. It was fun. Zach's getting better at it for sure. I enjoyed it. Yeah, I think the 16 versus the, what was it, like 48 options at the end? 16 is much better. Okay, so this is -9/5. So what is that? Plus 45/5. So that's 36/5. Jeff, when are you going to play? You should play 16 with us. It's kind of fun, actually. Sorry, did I get that wrong? 56? Where's the 56? Where'd I fuck up? No, yeah, right? Yeah, okay. I think I'm okay. No, thank you, honey. No, you're not. Honey, you're not stupid. I'm definitely getting tired. So I will start making mistakes. Oh, so just 3 + 1 is equal to 4. Okay, so D is equal to, do they just want, find the vector D? Yeah, great. So vector D is equal to 36/5, 2/5, comma 4. I only play games named after prime numbers. What?
No.
What the fuck? All right, cool. Good question, Calvin. Yeah, Christian. Hey, if you want to submit an eigenvectors question to the queue, I will do it. And because like you've never asked a question before, I might like let you skip the queue a little bit. 'Cause I don't know how many people are actually still here watching from. We've been going for a while. Let's see what are we at on the queue so far. Oh, not too bad. Parm Bagel asked this question 2 hours ago. Oh, this is kind of fun, though. Let's see. As new packages are unloaded from the back of a truck, they are slid down a ramp and stopped by the large spring at the bottom. Wow. It's conservation of energy, I think, right? I think this is a conservation of energy question. This is conservation of energy. We're gonna assume like the spring is like see, but if the spring gets compressed, it technically decreases the height as well. Right, clickbait? Yeah, this is a fun question, yeah. Oh fuck. Okay. I think I'm gonna put it here. Or yeah, I'm gonna put it there. I'm gonna say that's height equals 0. Right? I guess I could say the compression is, but nah, I'm just gonna leave it there. Okay, this is 30 degrees. The length, so the length of the ramp is not including the spring. Right? And that's 3.45 meters. And then mu s, or mu k, sorry, is equal to 0.51. Okay, I think we got all the information. Okay, so before energies. So you do have potential. So that's going to equal to mgh, which will equal mg. And then that's going to be 3.45 sine of 30 degrees. Right? Right. So this height here is equal to the hypotenuse, 3.45 times the sine of 30. I can see that. The cool thing is, yeah, kinetic energy is equal to 0. Yeah, there were a lot of cool ones today, Fembox. And then K-spring is equal to 0 as well. Cool. All right, now it compresses, though. Interesting. Now, wait a minute. Is there friction while it's compressing the spring? That's the question, right? Can we assume that the spring is frictionless, maybe? Yeah. Because I bet the simple answer is for mu g to be equal to 0 here, but I'm going to take it a little bit further because technically the amount it compresses also contributes to like a decrease in gravitational potential energy. So here, mu g is technically equal to negative mg, and then we would say delta x sine 30 degrees. Because this thing will slip this way down, and the amount of height it drops is delta x sine 30. Okay. Kinetic energy is still 0. Spring energy, that's going to be 1/2 k delta x squared. And then here's the key thing. We do have energy from the friction. It's like friction lost. No. So coefficient of static friction. No, that's kinetic probably. That's a high kinetic constant, to be honest. But this is going to be equal to mu k Fn. And then it's going to be 3.45. Like, do I want to say plus delta x? I think I kind of have to, yeah. This is going to become a quadratic. It's kind of ugly, actually. And then Fn is equal to mg cosine 30 degrees. Oh, wait. Wait, sorry. Is at the top of the ramp. If the spring at the bottom ramp has a spring constant of 0.200 and a coefficient of... Yeah, dude, this is my question, dude. What? Well, we're saying how much is the spring compressed? Wait. I assume this is the friction on the ramp as it's sliding down. I don't think that has to do... I don't... Yeah, I don't think it's a damp spring. Dude, I don't think they're making... Yeah, I don't think it's that tricky. I see what you're saying. Is that the spring would get compressed, and then you could argue that the force of the spring fighting the force of friction, trying to keep it, like, steady. Right? I think they meant to say that... Yeah, it's a harmonic oscillator. It's a damped harmonic oscillator. No. I think what they're meaning is that the friction here is equal to 0.51. It's worded a little weirdly. Cool. Okay, so then total equals total. So you have mg 3.45. Yes, I will submit it to ChatGPT. I am curious. Is equal to negative mg sine 30 degrees delta x plus 1/2 k delta x squared plus mu k mg cosine 30 degrees 3.45. The final answer is it never starts to slide. Well, then why do I care about how much is it compressed? Right? Okay, let's see. Let's see if it is being that tricky of a question. That's funny. Oh, you're JKing? I can't tell anymore. I think the way we're doing it is correct. I'm just curious. Right? We agree with the L plus X. Cool, cool, cool. Interesting. They don't count the negative. I know we don't. I just want to see. I want to see how AI interprets the wording because we're having like debates. Notice how AI does not consider. It doesn't consider the drop in the gravitational potential energy due to the spring compressing. Yeah, it doesn't do it. So I should say it like, forgot to account for the. Yeah, because this is the cool thing about chat. You can correct it and be like, hey, you forgot about this, and it's like, oh, okay, yeah, I did forget about it, right? So now it's L plus X sine theta. Yeah. Let's see how much that changes the answer though. Wait, 2.75 meters compared to 0.44. Dude, according to chat, changed it a fuck ton. Okay, I don't trust chat now. Yo, what? Yo, chat definitely made a mistake. All right, let's do it ourselves. We can do this. We're smart. We're humans. We don't need a clanker to figure it out. I'm pretty sure we can do this one. Let me get all my units. So M equals 235. M equals 235. All right, so let's figure it out. 235. The spring constant is light. It's 220. I'm just gonna round things. Actually, 3973. I'm gonna be an engineer for once and just get. I just want decimals at this point. I agree. All right, so we get. So we get so 464 is equal to 110 delta x squared minus 135 delta x. Okay. Let's move that over. Equal to 0. See what we get in the calculator. Should get a root. Interesting, okay. We do get 2.76. Thanks, Machka. Which is kind of what they got, 2.75. Okay, cool. Nice. Yeah. Good. Okay, we got this one right. Nice. Chat was right on the second one. I think chat was probably wrong on the first one. Or I guess this, dude, that spring constant's really small, right? So it actually would make a big difference, yeah? Alright, this was Parm Bagel. Chat was right. See what we got next. Dips. Nice. I like this. This is a fun one, actually. More calculus. But alternate. We haven't had any chemistry today. Chemistry, 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 chemistry. If I keep saying it, TikTok will know. I should make more videos on chemistry stuff. That'll probably help. I haven't had much time to make my short videos. The streaming takes up a lot. Okay, determine the values of a and b such that the function is continuous and differentiable. Okay, so if it's continuous, this has to equal this at 0. So ax cubed, exactly. Yeah, exactly, Jeff. Oh, was that the one with the like the J numbers? It was like derive it for like the hydrogen atom, the n equals 2 or something. Like derive like the L numbers or something. Yeah. Like L can go, so L can go from like negative n. No, L can go from 0 to n minus 1, I think. And then M sub L goes from negative L to L. Okay, sorry, this is 0. So at 0. Oh, wow. That goes away, right? 0 equals 1 minus 2b. Oh, great. So b equals 1/2. Love. Beautiful. So yeah, f0 equals f0. I guess we could say this is like f0 minus equals f0 plus. Oh. Did you post it? I mean, I can take a look at it. Maybe Joseph knows about it. Joseph does a lot of chem, right? No barks because no limits shown. Okay. F prime of 0 has to also equal f prime of 0. Yes. Oh, he went to sleep? Oh, okay. Maybe if he streams again. I hope he streams again. We'll get to it. Oh, this is a chain rule. Fuck. Ew. Our product rule, really. So 3ax squared cosine of x. Yep. Plus ax cubed minus ax cubed sine of x, right? Plus b. And that has to equal 2 times 2 over the square root of 1 plus 2x. It's due in 2 hours.
You're not that guy, pal. Trust me. You're not that guy.
What's up, Jaden? What's up, dog? Alright, plus a. Okay, but at 0, bing bong.
Bing bong.
This all goes away. B is equal to 2 over 1 plus a. B is 1/2. 1/2 equals 2 plus a. So a equals -3/2. Wow. The chain rule's wrong. Is it? Oh, I don't think it is. What? 1 plus 2x to the 1/2? Isn't that 1/2? 1 plus 2x... Oh, to the minus 1/2 times 2? Oh, so there should be another thing there. So that should be 1. 1 plus a. Yes. Can I explain KISS? Keep it simple, stupid? It's a pretty good one. A equals minus 1/2. Is it okay now? Josh, do you think that's good? We did your question earlier too, by the way, Josh. I think, or no, was that Joseph? Who was it? Wait, you think 2 was correct? Wait, did I fuck up? Yeah, equals 1. Sorry, but the derivative of this, right, is 1/2. 1 plus 2x to the minus 1/2, but then times the derivative of what's inside, which is times another 2. Derivative of 2x. What's up, Sup? Or Jaden? You wanna come up to the stage? What's cracking, dude? Oh, you're Deeps. Oh, thank you, Deeps. Okay. That's correct answer. Okay, nice. Okay, B equals 1/2. A equals -1/2. Great job there, Dips. Good job, dude. I will say it does help if when you guys submit your questions, if you put try to put the username that you're using on the platform you're on. I mean, you can always tell me that, hey, that's mine, but it helps me to identify who it is. Just in the future. Also, because I can see all the people that are online, which is cool. And so if I can see that, that allows me to understand, like, who's waiting for their question. Because if I see you're in the chat and your question's in the queue, I'm probably more likely to pick it. Yeah, please put your home address as well. Can you help me? I just sent in office hours. Yeah, I got you, dog. Which one you help with? Number 1 or number 2? But nice. Dips, good job. I posted your question and the solution in our Discord. So if you want to go join our Discord, let me know if the link's not working. Someone said it was weird. But right here. There's your solution. And if you come claim it, I'll give you points. And with the points, you can buy gift cards and stuff. Sup, which one you need help with? I'm gonna guess it's number 2.
send it in. Not
Yeah,
just
this one, number 2?
1, 2. I just sent it in. One. I sent
pick-
it 1, 2, 3.
You sent me 3. The whole
Office
question.
hours.
Okay, I don't have enough time to do all of them, so you pick. Which one do you want me to do? Pick one.
Number 2. I don't understand.
You don't understand number 2. Okay, let me do number 2 then. Sorry. That's okay. So here, yeah, let me pull this in. Okay. Amos took a short-term loan of $6K. The interest rate was 6% per year, 9% per year, compounded monthly. He managed to repay the full loan plus interest after a year and a half. So I'm gonna assume he did it in one lump sum, and he's not like paying it off as it's getting billed, because that's even more complicated. I'm just gonna assume like after a year and a half, he just pays it all off. How much interest did he pay? So this is the equation here. So it's here. Let me use a different color for you, Jaden. Sorry. So A.
So it's a compound interest.
Sorry.
Is there a compound interest?
Good. Yes. This is the equation for compound interest. A equals A naught, and then it's 1 plus R over N to the NT. Okay?
I don't understand what it means.
Okay, I'm gonna explain it. This is the initial amount you start with. That's 6,000. Okay? A naught is, this is the amount you owe. This is the initial amount you owe. Okay? And then this is times 1 plus R here is the rate, which is this. So 9% means R is 0.09. Good. So this is 0.09. And then they say compounded monthly. So in this case, N is equal to 12. Monthly means once a month, which means 12 times per year. So N is equal to 12. N is the number of times it's compounded per year. So do you understand what N would be if it was daily?
1.
No, 365.
Oh.
Because there's 365 days in a year.
Alright.
Okay.
What's the difference between compound and simple interest?
Compound means that it's building interest on the interest. Simple interest charges you a fixed percentage per year and doesn't worry about like fining you more for the stuff it's already fined you. Compound interest is a motherfucker. It's how like credit card companies like make tons of money. But so let's say, Jane, for instance, that I give you $100 and I say I'm going to charge you 3% interest, okay, per year, right? How much would you need to pay me after a year?
8% times 100.
Yeah, so $3, right? 3% of 100 is $3, right?
Yes.
So you'd have to give me $3. Okay. What if, okay, and so the next year, right, you would give me another $3, right? You would just keep owing me $3, yeah?
Yeah.
How compound interest works is the second year that I charged you interest, I wouldn't charge you just 3% on the 100. I would charge you 3% on the 103. So you owe interest on the interest.
So interest on the another interest.
Yes, that's why it's compounding.
Oh.
Compounding means to pack or like to pack on top of each other, right? To like stack something. So it's like the fines, which is the interest you're paying, is like stacking on top of itself. That's why it's called compound interest. And it sucks. Okay,
Wait,
so yeah.
Let me get out. I'm gonna get out the exercise book.
Okay. Well, let me finish this question for you, because then I do have to go. I only have 8 minutes left. So after a year and a half, right? That's the amount of time that you were paying for interest. And that means T is equal to 1.5. Because that's a year and a half. 1.5 years. Okay? So now you can just figure this out, right? So this is, according to the calculator, 6,000 times 1 plus.
What do you mean a year and a half?
A year and a half, because that's how long they said it took you to pay it off, was a year and a half. Like 1 year and a half of a year. So 1 year and a half of a year is 1.5 years.
It's like $1.50.
Yes, exactly. You're right. Okay. So this is what you get when you do the calculator. You get 6863.76. So how much interest did you pay? So the interest is equal to that minus that, right? So the interest...
Why do we need to minus?
We do need to minus, right? Because this is the total amount you pay. So you're paying back the 6,000 that they already gave you, plus 863. Okay, so interest equals 6863.76 minus 6,000, which is equal to 863.76, which is exactly what Jeff said. So nice, good job.
Okay.
Nice.
What is simple interest?
Simple interest is you don't have any of this R and T stuff. Simple interest is just P equals P naught RT, I think is what it is.
Okay.
Yeah. So here, I'm gonna put this in the Discord, the channel below it called Homework Help. That's where like I put all the screenshots of everything I've done for you guys. Simple would be 810%. Yeah. Yeah. So here, Jane, the equation for like simple interest is just PRT. It's just principal times rate times time. So in that case, it would just be the 6,000 times 0.09 times 1.5. And that's the simple interest. So here, I'll put this also in the screenshot for you. Cool? What's going on in, were you in Malaysia right now, right? Were you in Malaysia?
Yep.
What time is it over there? It's probably like not a crazy time, right?
12:55 p.m.
Yeah, it's the afternoon for you. It's like fucking almost midnight. Or it's getting close to midnight for me. It's getting late. That's actually only 9 p.m.
No.
All right, cool. All right, well, I hope that helped you, dude. Let me do one more person's question, then I got to end the stream. Water isn't instinctual. What's this guy's username, dude? What? Okay, I got 4 minutes. What am I going to do? Am I going to do this question? I don't think so. I don't think I'm going to be able to do this. Nice. What's up, Norgon? I'm a 9th grade student, 15-year-old who's very interested in math.
Yeah.
You found the right stream. What's up? What's up, Jaden?
Yep. I'm also 9th grade.
You were also 9th grade. Yeah, we also have other people from 9th grade from all over the world, actually. It's really cool. So, yes. Make sure you go join our Discord, by the way. Norgarden. Oh, thank you, Clickbait. Shout out to you, Dr. G. Thanks for creating this community of educators, my friend. I'm glad the algorithm god introduced us. Yes. Yes. Yeah, if you want to submit it, I have to end the stream in 3 minutes, but please do submit it. Because anything that gets put into our queue right now, if I don't get to it, which I won't get to it in the next 3 minutes, it gets put into our Discord. So make sure you also join our Discord. And in there, we have a bunch of other awesome people who love to teach or just like solve hard problems and help you guys out. And so they might do it as well. Or like show you how it's done. Or it would probably be like a fun challenge to go through anyways. Okay. But I got... Glad you made it here. Yes, fem. Yes. We're so glad. Clickbait, you are a gem of a person. I appreciate you, Clickbait. Yeah, make sure to join. Let me know if it's not working. Someone said the link was having issues on the Discord link. I hope it's not. I hope it's working. I think it's like some of the international people have issues with it. If it doesn't work, just go to like Google and type in like actual education Discord, and then like any one of these links should work. Yeah. One of them should work. All right. I don't think I can do this one in 2 minutes. It's a cool question though. Let's see what else we have. Ooh, this is probability. Much better than trying to build relationships with these children I'm in school with. Sometimes you gotta learn how to, I don't know, dumb yourself down. Or speak brain rot. The link is in the description. Yeah. Well, so it is also, if you go to the website to submit your question, the website is www.actualofficehours.com. This is where people are dropping screenshots of their stuff. And then you can hit join our Discord and that should work. Okay, I don't think I can do any of these questions in like a minute. Sorry, I've been running out of time. This is so cool though, man. I love this. This is a great probability question. Fuck. I really have to go though. I've been streaming for 4 hours already. Bungus, I like your question. Ahmed, I like your question as well because this is fun. Statistics. Yeah, you know what? These are great. I'm going to talk to Zach, and I'll tell Zach that maybe if he wants to go through, we had a couple really fun. Yeah. Yeah, this is also cool. I like all your questions, guys. Ooh, this one. Log of X? Yo, how do you integrate that one? Okay. All right. I got 6 seconds left. So, yeah. Ask E to the 2i Pi. Yes, he's going to be on in about 10 hours. So, go ask him. Okay, cool. Let's end out the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate it. It's a fun little Friday night with you guys. Lots of fun questions. I really wanted to get to the other ones. There were some fun ones in there, but alas, I do have to go. But not to worry. Again, make sure go to the website actualofficehours.com. There you can. Thank you, Jorgen. I appreciated all your insight as well, Jorgen. Yeah, I have such an awesome community on all these platforms. I love you guys. Thank you for sharing your passion for math and science and learning and all that fun stuff. It's great. It really makes it worth it. But if you want to keep the party going, make sure to click here on the streaming schedule, and this will show, because I'm not the only person that does this. There are a lot of other awesome people who stream free help. This has a calendar of all the different streams that are happening, and it's updated like pretty instantly. So if ever there's like a last minute change, you'll see it on this calendar. So Zach is streaming at 9 a.m. So 12 hours from now. Zach is going to have his own little math help stream. And then next week, we got some awesome events. Penn Center's got a fun podcast series where he talks about like math and teaching stuff, which is great. And then, yeah, more streams. We will be here. So make sure, go check this out. And if you're following us on, TikTok, maybe give us a follow us on YouTube. That's where all the recordings for all these streams are posted. So if you want to go back and like rewatch what happened. Also, if you want to watch on Twitch is the best platform to watch us on because it's nice and it has like this really cool looking, like it's horizontal. So you can see myself. Like this is the stream. It's really cool and horizontal. But this is also Infinity Me's. What's my sister's Instagram? I have 5 sisters, Jaden. I can't give you all 5 of my sister's Instagrams. It's okay. All right. That being said, I'm in a math training camp for the Baltic Way. That's why the lesson I missed it. Well, cool. Then yeah, post the question, Norgarden, and I'm sure someone else would love to explain it to you. Or if not, Zach can explain it to you tomorrow. It's a cold vortex. All right. We're going to go raid somebody. So who are we going to go raid? Who else is on tonight? Yes, you have a great night as well. I hope you feel better. What's happening? Streamer Awards, Gem nominee, DJing, space news, stuff with stuff. Here, let's go say hi to Science. Science has been on. Let's go say hi. It's a Friday night. All right. That being said, enjoy the rest of the week, the start of the weekend. We will see you guys on Sunday. Peace.